I prepared 4 sets of slides, which means I prepared way too much to cover. So let me tell you what I want to do in these lectures. A recurrent theme in the lectures, and I guess it's going to be 2 economists and 1 sociologist, will be on trying to think about the integration of social ideas into, or sociological ideas into economics. And for better or worse, the terminology I'm going to use is to call them social interactions. And the way that I want to organize the lectures, and I'll just go as far as I can, and whatever else I don't cover, is first to give you a fairly high-level overview, and then I want to get into some of the technical specifics. If I have time, I want to give you an application of these ideas to intergenerational mobility, and hopefully that'll be possible. Okay, so as I said, the first thing I want to do is talk about what I think are the general ideas in this literature. And really what I want to put on the table is something I'm going to call the membership's theory of inequality. So not membership, but membership's theory. And the idea is going to be to put on the table a theoretical template or conceptual template, and then ask questions and try to then develop it. And so what I mean by the membership's theory of inequality is really 3 propositions. The first is that in thinking about individual outcomes or behaviors, that the different constituents of those, when one thinks about the constituents of those phenomena, there are social factors. And so standard operating procedure in economics is to conceptualize outcomes as derivative from the specification of preferences, constraints, and beliefs. And what the social interactions literature does operationally is, in modeling preferences, constraints, and beliefs, to embed specific social phenomena in them. Now, to be clear, when if you ask me personally, what is, define the irreducible logic of economic theory, one of them would be this notion of a certain form of methodological individualism, that we think of individual outcomes as derivative from constraints, preferences, and beliefs. Let me also be clear, I don't consider that to me is a tautology. It's not interesting. What gives the theory substance is what determines these 3 components, or these three determinants. And what the social interactions perspective is trying to do is to augment conventional, more neoclassical perspectives with other ones. Now, in saying that, there's going to be a specific mathematical property that links social factors to preferences, constraints, beliefs, the constituents, and that property is complementarity. And there's a mathematical definition of complementarity. You write down a function. It has to do with cross-partial derivatives, or you can do it in more fancy lattice theoretic language. But there's a very simple intuition to all complementarity arguments, and that is that in specifying how social factors, social structure affect individuals, the influences tend to create correlated behavior. And so intuitively, my marginal product to working on a paper is increasing in whether my co-author, a certain L. Bloom, what is this? Certainly do not want to check for that now, okay, is working hard. That would be a trivial example. But if you think about more serious examples, the productivity of members of organizations is interdependent in ways that will create incentives for people to either work hard or not work hard. Students in school would make certain choices that are correlated, so on and so forth. Complementarity becomes essential because that provides a theory, as it were, of why we observe group-level differences. And the point being that the group-level differences are logically distinct from just saying the groups have individuals that have, their individual characteristics just tend to be different. And so the logic of complementarity is what makes group-level differences derivative from something that's intrinsically social. And one of the objectives of this branch of the literature is to develop theories of group-level inequality, be it groups defined by characteristics such as ethnicity or gender, or residential neighborhoods, colleges, so on and so forth, at many different levels. The second idea in the literature is that if we think about social structure, and I called it memberships here, which is really not the most precise term, but if we think about social structure, in many respects, social structure itself evolves in response to the presence of the social factors as they influence preferences, constraints, and beliefs. And so again, at this level, it's very intuitive. It says that if the social factors matter, to the extent individuals can influence, subject to their own constraints, what social environments they function in, that's going to happen. And so the reason this becomes important is that in having a theory or having a perspective on inequality, I want to say that, no theories of everything here, but rather a perspective on social determinants of inequality. It's one thing to say social structure affects individuals. A distinct question is what determined the social structure. After all, if everybody experiences the same social structure, the fact that social structure matters is not interesting for inequality. Upshot of all of that is that if one thinks about how social structure evolves in response to the presence of social interactions, that actually provides a way of conceptualizing why segregation emerges. Put differently, incentives exist for individuals to quote-unquote self-organize themselves or to make choices as to residential neighborhoods, what college they attend, so on and so forth, that in equilibrium will produce levels of segregation. Let me add parenthetically that when I'm going to claim economists use, this is for non-economists, you'll forgive me, the economists use the word equilibrium. That's not a statement that things aren't moving around. It's not a statement of a steady state. It merely says there's a conception of an environment, and there's a way we could talk about what the realizations are of the environment. The realizations are the equilibrium. So, yes?
Can you talk about what you mean by groups exactly? So you're saying they're non-overlapping, but should we just think about it in terms of sets of people that...
So the way I'd like you to think about it, and that's a great question, is in the heuristics, I'm focusing on the notion that we would think of individuals in which we could categorize them by gender, by ethnicity, by residential neighborhood, so on and so forth. That said, social structure is not non-overlapping. And so if I were to start it with a different primitive, I could have said the way I think about it is there's a population of 7 billion people. There's different levels of interactions between them. Every person has a pairwise interaction. Most of the weights, by the way, are 0, but nevertheless, we have all of these pairwise interactions. Then I have triadic interactions, so on and so forth. A different way to proceed, and this is how I'm talking here, is we think about these groups, and the totality of our interactions can be derivative from the fact that we have multiple memberships in common. All right? And so in that sense, strict conceptualizations of groups is a subset of general social structure. So what I have on the table, in other words, is 2 claims. One of them is that when social structure matters, that explains why you can get group level inequality that's conceptually beyond that which is generated by the facts that individuals in different groups have some individual characteristics that are correlated. Second, the social structure itself, because of these social interactions, there's incentives the individuals face when they make choices that lead to segregation. Well, if you put them together, that actually provides a perspective on intergenerational mobility, or maybe better said, intergenerational persistence. So the idea would be in this perspective that social factors matter. And so think about individuals across the life course. They're growing up. They experience a set of groups. The first group they experience is called the family, a sort of matching, mating of parents matters. The second thing they experience is residential, is the place they grow up. The third thing you experience is schools. Then you experience something called college. Then you experience your allocation in the labor market. That's a fancy way of talking about the group called a firm, so on and so forth. Individuals move through life across these different social milieus, each one of which creates a feedback. So once you start with this this is very grandiose talking, you have this perspective, you have a theory of intergenerational inequality that says inequalities amongst the parents, which are socially determined, lead the parents to face constraints that create differential social environments for their children, and that replicates the inequality across generations. And so if you put the 2 factors together, one has actually a theory of persistent income inequality. And that's the big picture that's underlying a lot of the work that's done in this literature, and why the focus on social interactions, social networks, neighborhoods, all of this is coming together from the perspective of economists as something that's important in thinking about inequality. All right, so the key, as I said, is going to be that is this interplay of, at least from the perspective of the literature, it's taking the tools of economic theory, the same ideas about how we model choices as derivative from this interplay of preferences, constraints, and beliefs, and we alter the constituents of those things in ways that produce qualitatively different implications for understanding both cross-sectional inequality as well as intergenerational mobility dynamics. So, in putting these things together, and I know Larry's already talked about this, that there's really 3 things I want to pitch on this. The first is that you've probably all heard the phrase economic imperialism. That's a Chicago tradition. In other words, going to other fields and making arguments that neoclassical economics can explain phenomena. This is this is actually, I will in this case speak with authority, that the people who work on this, it's more of a good faith effort to bring sociological ideas into economics, and we think it makes both of them better. The second comment's the following, and that is, if somebody said, well, what are social interactions? After all, aren't every model would seem to be social? You take the Arrow-Debreu general equilibrium model. There's a bunch of agents. They collectively interact. What's essential here is what makes the social interactions literature conceptually distinct is the way that people interact. In the Arrow-Debreu model, prices are the sufficient statistics for interactions. In this world, there are very different types of interactions that are transpiring. In other words, you have things such as peer group effects. We have role model influences. You have social norms, what have you. These are not objects that have market analogs, or they may be influenced by markets, but they do not have the Arrow-Debreu logic that they're adjudicated directly by markets. And so if you look at these models, they actually will have embedded in them, even though this is not often talked about, deviations from what I'm calling the pristine general equilibrium approach of complete markets, so on and so forth. The third comment I want to make, and this has to do with a way in which one part of the literature is that there's a very specific conceptualization of aggregation. In other words, the logic of these models is to specify individual outcomes. These individual outcomes are interdependent. And they're also the specification, the economic logic of them respects the fact that the theory is incomplete. There are things about individual behavior that we don't know. So why you say is not triviality? Well, the answer is not obvious. What matters is that in the specification of the individual outcomes, one respects both the observed heterogeneity, that's what the theory tries to account for, and the unobserved heterogeneity, the statement that there's simply, from the perspective of an analyst, things we don't have a theory about. What happens in the models then is that if I wanted to talk about the non-marital fertility rate of a certain group, or the college graduation rate of a group, so on and so forth. These are simply statistical regularities that emerge from interdependent populations. So no determinism, please.
What is the role of Galois in these new modeling approach?
Ooh, that's a complicated question because it depends on the, pardon me?
The welfare speaker,
Well, it would depend on, I would need a context, and that would be part of the modeling of I said there's going to be preferences, constraints, beliefs. People have outcomes. And so if you said to me that people are making choices about education, part of what I would have to specify is the economy in which these educational choices are going to manifest themselves. And I would have to model, to make that concrete, model the environment in terms of public education, student loans, et cetera, in which those choices are going to be made. And so if I said public universities complying with educational finance constitute aspects of government, then those would be things that have to be part of the theory. Okay. A different conception is there are models of welfare, participation in welfare, that try to consider social determinants, the role of stigma in affecting the use of public welfare. So there, when one writes down the model, I would want to be concrete. This is the public welfare program. These are the benefits that potentially accrue to somebody who participates in it. Then I would have to specify what I meant by stigma, exactly how that's going to be embodied in my theory or in my theorizing, and then I would work out the consequences. Okay, so one level is simply to say that if I talk about those three things, the government affects them. Okay, and so the government could affect preferences on cigarette smoking because it runs advertisements that make smoking seem disgusting. Or it could affect beliefs about smoking by running advertisements that say cigarette smoking has a certain danger. Or it can raise taxes to change the constraints, in other words, the costliness of those things. And so, but notice in every case, I have to contextualize to a specific phenomena or a specific set of phenomena in order to talk about the relevant government actions. All right, so this last part's important because part of what I want to push as an approach to doing economic theory, not the approach, an approach, is to be very insistent that the logic of writing a theoretical model is to respect observable heterogeneity, unobservable heterogeneity in such a way that at the end, what we call the equilibrium of the model is some joint probability description of the actors. And when you turn to data, that thing called a joint probability description is a likelihood function. So in other words, embedded in this is an idea that one way to do economic theory, which is, as I said, it's respectful of unobserved heterogeneity, preserves a logical equivalence between the theoretical description of an equilibrium and a likelihood function, which is the object for empirical work. Now you might say, that's so obvious, everybody should do it, it's so wonderful. Of course, there's costs to doing to that. In other words, there's going to be losses of generality with respect to functional forms and the like, and so there's always going to be trade-offs in terms of what a theory can accomplish, with respect to understanding, and with respect to its empirical implementation. All right, I think you've already heard these examples. There's many different phenomena of social influences, everything from peer group effects to role models, social norms, social learning. It's a very broad tent, so I don't want to say more about that. What I do want to make is a few comments about cases where social interactions have plausibly been argued to matter. And I want to be clear, there's good evidence on these, but they're still open research questions. So an obvious example is fertility. If you want to understand something about the dynamics of inequality, you need to know things about the marital status of parents. You need to know about the number of children. You need to know about the timing of children. No, these are not ethical statements. These are factual statements about tracing out inequality dynamics. In each of those cases, there's good reasons to believe that these choices about fertility and the like, they have social components to them. To give you one example that's interesting in economic history, the conventional theory of fertility at a macroeconomic level has to do with quality-quantity trade-offs. So the idea was with the Industrial Revolution, there was a qualitative shift in the benefits to investing in your kids, so families had fewer kids because they need to invest more, and hence you had the fertility declines that indeed happened throughout Europe during the period of industrialization. So that's a good neoclassical theory of fertility. The problem with the theory is if you look at the timing of the individual countries, the country who actually had the fertility drop latest was Britain, even though they industrialized first. And so I put this on the table first to say that, we're talking about economic theories. Obviously, the question is whether or not they're useful for understanding. That's an example where if I was doing things across continents, very useful. Within the continent, not so useful. And second, I'll merely put this on the table as an interesting fact. It turns out if you look at the timing of the fertility declines country by country in Europe, there's something that does a very good job of predicting the declines. It's the fraction of votes that labor and socialist parties received. So if that went above a certain threshold, fertility subsequently was lower. Now that's an example of a non-causal claim. It's correlative, but it tells us something which is the substantive theory, and that is that secular party support is then being used by demographers to study changes in social norms. And that's been and so the conventional theory is the support of what I call the left parties is a signal of the degree to which the society is secularized and contraception and fertility were treated more as choice variables. So just a nice little example from economic history of how these things work. Second example is education, where we know that there's very substantial heterogeneity in college and investment in education and college attendance and high school dropout rates, after one controls for the usual suspects in terms of standard calculations of marginal gains and marginal benefits. Why would I put this as an example? Just to give a recent paper that's extremely interesting by Caroline Hawksby and Christopher Avery made the following discovery. They found that basically the universe of high school students who took standardized tests a few years ago, and what they discovered, what they identified in the data set, were thousands of high test score poor kids who did not apply to particularly good colleges, in the sense that they were individuals who were certain to get full scholarships to this place and other very elite schools, yet were not taking advantage of those opportunities. But I should say, and that's called the undermatching hypothesis, the identification of these opportunities that are not being taken. Now, it is not clear why that is happening, but one factor that they did find was that if a student did not grow up near a college, they were more likely to fall into the undermatched category. That's a very interesting example of a type of social learning having to do with aspirations. And so I just put that on the table as a case where social phenomena seem to have some purchase. Employment is a standard example in this literature now. If you look at the flow of information about job opportunities via social networks, many studies have found substantial explanatory power in the matching process. Another example is health. If I asked you what is the leading preventable cause of illness and death in virtually every advanced industrialized economy in the world, the answer is the same. It's called cigarette smoking. And so if one wants to understand why an activity which has such massive social costs is initiated, so on and so forth, part of the phenomena has to do with the social relationships and the way that smoking is social norms are formed, peer effects happen, so on and so forth. All right, and I'll add there something that's interesting is if you look across ethnic groups and gender, there's remarkably high variation, subgroup by subgroup in smoking rates. And they are not correlated with the usual suspects in terms of family background and the like. Final example I will put on the table is an area that I think is understudied by economists, and I think great fodder for dissertations, and that is language. Here's a question. Why do millions of Americans use a dialect of English? And by the way, it's a dialect the same way that I'm using a dialect. Nothing's better than anything else. It's slightly different. It is perfectly comprehensible to everybody, and yet we know it has substantial labor market harms. Okay, that's African American vernacular English or Black English. There are very interesting studies by Jeff Grogger at the Harris School and others who identified that in the interviews, if somebody is slightly different pronunciation of words, slightly different internally consistent grammatical structures, has first-order labor market consequences. Understanding the issue of dialect is a fundamentally social question. All right. Now, dialects are not not purposefully chosen. Not all choices are conscious, but it's also an example where the sociolinguistics literature has very powerful things to say about that. And the argument, which now links to economics via the economics of identity, a la George Akerlof and Rachel Cranton, is language is a marker of identity, and so individuals end up with particular dialects that is because it has to do with their desire or the conscious or unconscious or the fact of their identification in certain groups. Here's a different example. If you look in I guess, Australia, New Zealand, Canada, the US, and Britain, there's a particular group of people that drop the G's at the end of words ending in ing, going versus going. They are disadvantaged white males. Okay, again, the explanations of that in sociolinguistics are that it has to do with identification. In other words, I named 5 societies that put a particularly high value on making money, and therefore people who are disadvantaged or feel stigmatized, so one of the reactions to that is disidentification. All right. So what I seriously put on the table is that there's very good reasons to believe that language is fundamentally either unifying or alienating, and that's something that social models with the logic of economics can make progress with. Okay. I can give you lots of other examples that are a little bit far afield, but I don't want to in the interest of time. All right, now I've mentioned groups, and this is partly to answer the questions you brought up, and again, it's not fully satisfactory. I talked about groups because it's easiest for me to think about their formation. And what I want to put on the table are these are kind of the 3 canonical examples of groups that are endogenously formed. So if I want to have a theory of social interactions and inequality, at the end it's one thing to say the groups matter, the others have to say who's in the groups. And so the canonical examples would be residential neighborhoods, firms, and schools. In contradistinction, one could put on the table ethnicity, gender, and religion. Now, my point is not that these are exogenous, nor am I claiming they're binary. It's rather to say that in the modeling of these phenomena, the question is how much is lost by not modeling the endogeneity, and there is, I believe, a qualitative difference between the 2 categories. That said, I want to put something on the table that is an outstanding research that nobody's done any work on. Okay, first of all, your question is I really want to go beyond groups and not just think of our interactions as the aggregation of our overlapping memberships. That's actually doable with something called sociomatrices. The second thing is the hard question, and that is why are some groups salient? Professor Bloom, do you not agree that that in terms of role models, bald economists over the age of 50 should have particular salience? Of course they should. Okay, that's the normative statement. The positive statement is they don't. All right, so the serious point is obvious. But the point is that's about you, not the group isn't the point. It's the Bloom group that matters. Okay, the serious point, of course, is that if I say to you, yes, some of our ethnicity is fundamental in understanding identity, understanding discrimination and the like, gender fundamental for these things, that does beg the question is why are these groups salient? And there's an infinity of ways to carve the human race up into groups. And so we don't have good theories now of salience. I think part of the answer probably is economists don't have much to say about it because there's historic contingency in these things, and that's outside the domain of what we would have something useful to say about. But nevertheless, I think there are theoretical questions that are worth considering. All right. So what I want to do is just make a couple of comments about what the logic of social interactions models, just to repeat something I started off with, which is that if I were, if I were to write down this is kind of how I want to talk about choice and talk about equilibrium and all that, is that if I think of individuals, they make choices, little omega i's, each person has a constraint set, big omega I. I want to, as I said, I want to be very careful in always distinguishing heterogeneity that's part of, that I model as part of the theory, and heterogeneity I just take as something that's outside the logic of the theory, and that's the distinction between x's and epsilons, which should remind you of a regression, and that's what I meant about preserving parallels always. When I say to you there's a kind of an economic model of these choices, I'm giving you a tautology. I'm saying that tautologically, we think of the things we observe, the outcomes for individuals. They maximize a utility function, some payoff function v, that takes as arguments the omegas, the x's, and the epsilons, and maximize subject to a constraint set. To say this is to say nothing, because it has no restrictions on the world. All the action is in how I specify the payoff function, how I specify the constraint set, and how I specify the way that people formulate the relationship between means and ends in a probabilistic sense. Social interactions models use exactly the same choice-based logic, and again, focusing on groups. The idea would be to say each individual is a member of a group. All right. And then I want to say the following, and that is that if I'm a member of a group, relative to the other people I'm interacting with, there's things about them that matter to me. Those things come in two flavors. One of them is I care about what you do. Those are going to be the behaviors of others. And I'm going to say that I have beliefs about those behaviors. I'm going to call them subjective beliefs. It means that they're mine, that's all. And the second thing is there's characteristics of others. And I'm going to call those characteristics Y's. So in other words, I sit there in this social structure, there's some other people, and there's stuff I know about them, or stuff I think about them. And to say that I have a social interactions model is to say nothing deeper than when I model the individual choices, they maximize a payoff function that has richer constituents of the arguments that directly enter the payoff function and the way in which they influence the constraint sets. Okay, that's it. And so the reason I emphasize that is there's some tendency in parts of this literature to claim that this is something qualitatively different or new in terms of the economics. I actually don't think it is. In other words, that the same logic of being precise about the way we specify individual decisions or individual outcomes combined with some notion of an equilibrium, which is just the way that the interdependencies are adjudicated, that is all ported over from very basic economics. What matters is the way in which I think about how my beliefs about others affect me. The way in which I specify those beliefs about others is a perfect foresight. After all, if the two of us are writing a paper together, I don't form a belief about what Larry's doing. I talk to him on the phone, he tells me. On the other hand, if you're asking me what the fashion is going to be when I'm a senior in high school for all males in the United States, then I form a belief about it, so on and so forth. And then the third thing, of course, is to specify how constraints versus preferences are affected. So, all right. Now, I think this has been talked about, but in the back of your heads, I just keep kind of three things in mind in terms of understanding what are the things that the theory wants to capture. Please.
Can we go back one slide?
Well, now I'm afraid.
I want to interrupt the flow to ask a question. I want to say that I've received a number of questions and comments during the past week about the Akerlof-Cranton identity framework.
Mm-hmm.
This relates to that, and you can see it best here. Do you have anything you want to say about that?
Deep, no. What I would say is Akerlof-Cranton, the way that I would define it is that you have to say preferences, payoffs over what? So I could say that introductory textbook economics, payoffs are over the consumption of commodities, right? And so if I were to write down a model of how hard do I work in school, the neoclassical analog is I work hard in school because it affects my income and I get to buy commodities. Everybody with me? So in that sense, very, very narrowly defined human capital theory is a very simple extension of what you heard in the textbook. Akerlof-Cranton would say something else. They would say part of the utility, the payoff I get, is that I have a conception of the person I wish to be, this type of person I want to be, and I get utility from payoffs from behaving in ways that are consistent with that. And so what they would do is they would add to the human capital, and I know I'm sorry to be talking this through verbally, they would add to the specification of I call it the neoclassical, how do you work in school, where I get a payout, there's a disutility to work, and there's a utility from working in terms of future income flows. I'd add something else, which is the type of person I want to be either perceived as by others or perceived as by me. And conditional on that type of person, there are behaviors that are associated with that type of person, and therefore I conform to those behaviors. So I would say that in that sense, I would force it into a notion of a conformity effect, but the meat of it, the logic of it, the substantive logic is that people have conceptions of the person, as I said, who they want to be or they want to be perceived to be. And so in that sense, I would say that it certainly is a social interactions model.
And I think it's worthwhile pointing out here that that we have limited ways that we can express complex social concepts in the framework that we have, right? We have payoffs, we have preferences, and of which beliefs are a part, and then we have constraints, and that's it, and we squeeze a lot of things in. And I think what you described is a particularly artful way of squeezing into, basically conformity effects, a richer story than we would normally associate with that.
And then to push this harder, I say as we think about the empirical analogs, it does amount to saying you have to then model what is, identity is going to be a function of some stuff that's observable, and then that's how empirical work would proceed. Please.
Where do you place family as a social member? Is it membership?
Oh. So you ask me the vision I have. The vision is the first group is the family. Then there's another group, and so you remember these different groups. It's family, local neighborhood, broader community, school, college, firm. So I would just put that in as one of the constituents. Now that's a cheap answer for many reasons. One of them is I don't really think the logic of family economics, outside of a sort of the mating issue, the matching issues, really the social stuff has all that much to say. The second point is I don't want to put things on par. In other words, I think it's important in thinking about, let's say, residential neighborhoods affecting people. We want to sort of build on the top of the families. And so we can sort of start with this and then ask what you add to it. So I'm not sure if that is answering your question particularly well.
Yeah, and so I think the family is a deep membership. Something that doesn't really fit in there, and yet it exercises so much influence over inequality. It's one of the
Well, the sense in which I'm not sure that it's important that for these theories have something useful to say about families is the principled empirical distinction is between variables that are indexed at the individual level and variables that are indexed at higher levels of aggregation. And so in that sense, my mother and I have the same index. So if you're talking about me, my mother had an influence on me, my father had an influence on me. That's an I index. Your I prime, I would still have the I prime, your mother, the I prime, your father, so on and so forth. Whereas what's going to give these theories action is the more aggregated ones. The only place I wanted to push a little bit is that if I thought about an intergenerational mobility model, I can ask questions about mating patterns. In other words, do we observe, here's an empirical fact, we observe increased segregation of marriages by education. That's, I don't think that's a first order issue in intergenerational mobility, but it's not a meaningless question to ask about. So on the theoretical properties, Larry's talked about social multipliers. Let me talk about 1 and 2. One of the things these models can generate are multiple equilibria. And the way I want to define multiple equilibria is I said, we have micro foundations. We specify preferences, constraints, and beliefs. That means that individuals have rules of behavior, and there's an equilibrium configuration of choices. That's the adjudication of the rules. A question is, do the micro specifications uniquely entail the aggregate outcomes? And these models often will have multiple equilibria. So in other words, the answer is no. The intuition for that is a consequence of the complementarities that are built into the models. If I say that our decisions are highly interdependent, the one thing I know that tells us is we'll do the same thing in equilibrium. But it may not tell us what we do. And you knew that from basic coordination games. And so there's a powerful idea from the elementary examples to the general principle, which is strong complementarities introduce a degree of freedom in what actually happens. And so you see multiple equilibria throughout these environments. The second property I wanted to put on the table is something called phase transition. Now what's interesting there is the following, and that is, let's think about a world in which we're arbitrarily interdependent. So the way it works is, if we do the same thing, we get a payoff of $1 billion, and if we do different things, we get a payoff of $1. Okay? Everyone with me? You all agree that we're either going to do one or the other because we want the billion. What if I started off and said it was 0? Or actually, it was $1 in all states of the world. You'd agree that equilibrium doesn't matter what we do, right? So we start off with unique equilibrium. I start cranking up the payoff to being coordinated. Eventually, I hit a point where multiple equilibria emerge. That's called a phase transition. In other words, what happens in these environments is they're highly nonlinear. That's the social multiplier idea. They'll have one qualitative set of properties. You keep changing these parameters, and suddenly things change. And so that in the relevant mathematics and physics is called a phase transition. You were all familiar with phase transitions in nature. Something very strange happens to this thing called water when the temperature goes from 32 degrees minus epsilon Fahrenheit to 32 degrees plus epsilon Fahrenheit. There's a qualitative change. These social interactions models exhibit analogous qualitative changes. And so you get segregation emerging, or you get polarization of groups emerging as these interdependencies move across very particular thresholds. And that's obviously an interesting property of a model and something to think about. The classic example in the social science literature is Thomas Schelling's segregation model. And so Schelling's question was, why do we observe, we observe extreme patterns of racial segregation? One explanation would be because of extreme preferences. Whites don't want to live with blacks, period. What Schelling showed was you could have mild racial preferences and still get complete segregation. And these environments exhibit phase transitions. What would be the intuition? Think about a world in which you have two groups, equal sized, and everybody follows the rule that they never want to be the minority in a community. Everybody with me? I could have two perfectly integrated neighborhoods, nobody's a minority. That's not a stable equilibrium. Once you permute it slightly, the only stable equilibria are complete segregation. And so you have these interesting phase transitions, and there's a phase transition at 0.5. If it's 0.4, a little bit below that, then you can get, things will be qualitatively different. All right, so those are kind of the things we look for from the perspective of the theory. I'm going to throw out a Santa Fe Institute jargon. The properties are quote-unquote universal, and what that means is phase transitions and multiple equilibria hold for many different specifications of the interaction structures. That's important. They depend on the collective dependence of the system, not the details as to whether or not you react to people that are 1 unit apart, 2 units apart, 3 units apart. Those types of details, the properties exhibit a robustness with respect to them, and that's quite important. And as I said, the models are intrinsically nonlinear. All right, that's really all I want to say about high-level theory. Now I want to make some comments about evidence. So if I were on trial and there was a prosecutor, Homo economicus generation X minus 1, saying social factors don't matter, the neoclassical model, as you learned it in your first textbook, is fine. How would I make the empirical defense? And all I want to put on the table are the following, and that is there's really 4 sources of evidence in the social science literature, some of which economists have not really contributed to, and I think economists tend to ignore to their peril, and then 2 that we have made contributions. Okay. The first evidence is, I think, ethnography. In other words, individuals embed themselves in communities and write thick descriptions of the communities. Classic researchers, Mitchell Denier's last name is misspelled, which is bad since we're personal friends, and Elijah Anderson. This is something where there's a very powerful and ongoing tradition in sociology. I think that this evidence economists tend to underappreciate because it's qualitative. Now, the reason I think it's important to appreciate is at the end of the day, when I talk about identification problems in econometric models, they're going to come down to judgment. They're going to basically, if you make no assumptions, nothing's identified. It's not a shock. If you make assumptions, things can be identified. How do you justify assumptions? They have to be from information sources outside the model. And ethnography is an excellent source to get insights into what sort of identification assumptions are more or less plausible. The other comment I want to make is that I think that it's very valuable because of the heterogeneity that emerged, the ethnographies document. In other words, that we have to avoid these deterministic models. That a poor neighborhood is a literal poverty trap, where everybody with probability 1 is going to be there. We have to have a stochastic process conception in which poverty traps are really statements about conditional probabilities having been altered, and there being interactions by isolating poor people that create certain nonlinearities. And so I think the heterogeneity is as important a message as the descriptions of the group level differences. Okay. Second set of studies of this type are really, I want to put them in social psychology, even though economics is rich in experiments. I think that the classic powerful evidence is in the social psychology literature. Did you talk about Robbers Cave? Okay, then I won't. Did you talk about obedience to authority? All right. So here, the news is the following, is that IRBs would not allow any of these experiments. And so one of the things as good social scientists you want to do is read the social science literature, and there are classic social psychology studies that are of enormous interest to us. So the example I want to talk about was obedience to authority. Obedience to authority is the most famous, I think I could say it is the most famous experiment in the history of social psychology. And it tried to answer one of the most horrible questions in the history of the world, which is, why did they do it? And so after the Second World War, there was a question as to why millions of people participated in the Holocaust. And so Stanley Milgram was a psychologist at Yale at the time, so this was in the late 1950s. He ran an experiment. This is how the experiment worked. So remember, Yale is at this time was all male, extremely aristocratic. I'm sure there was some exceptions. And so here's the experiment. You go and you've decided you volunteered to work. You're the dupe. I'm sorry. You come to the laboratory. I'm wearing a stethoscope and a white coat. She's hooked up to a device, and you're going to help me monitor her reactions. It turns out that I don't know if people know. So the experiment is to see whether or not I can get memories to come out of her. So you start turning up the electric current. I ask her, do you remember something? She says no. I say, turn it up some more. So eventually, this person says, I'm very uncomfortable. I can't take it anymore. I say, I'm the doctor. She's fine. Keep going. Keep going. Eventually, you say, I have a heart condition. I'm going to die. I'm the doctor. And I say, I'm a doctor. She keep going. Blah, 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 blah. Okay. So the question, does everyone see? So the question is, how many of these Yale undergraduates turned the dial to the maximum? Remember, these were not people who had 11 years of Hitler Youth propaganda. These were the children of the American aristocracy, the good guys. What fraction of the undergraduates turned the dial to the maximum, even though the person wired up said they were going to die? Pardon me? I want a number. This is economics. Remember, we're obsessively quantitative. What's the fraction?
30%. No, 80.
All right, it's 70. We have a patriot. Okay, serious point. It was 70%. All right, that was a shocking result. Here's a second result. Take the same experiment. You're working for me. So I'm sorry, you walked in. Two people are controlling the dials. Everybody with me? So I keep telling them to turn the dials up, and they keep doing it. At some point, he has instructions to say no. What happened to the Yale undergraduate when somebody was willing to defy authority?
They also would.
Yes, everything changed. So there's another message. Certain types of changes in social structure have huge consequences. And so again, I'm not saying we extrapolate this these fascinating results to understanding peer group effects in smoking, but they tell us something, ways to very cleanly identify certain ways in which behaviors are determined. Please.
Yeah, I want to add something to this description. For those of you who think that IRBs are a pain in the neck, there is a Yale, actually he might be retired now, there's a Yale English professor who as an undergraduate was a participant in this experiment. And he wrote an article that was published in 2000 in a local New Haven magazine, where it's very clear that his participation in this experiment, I don't know how many years after the fact, the experiment was done in the 50s, early 50s,
Yeah.
right, so it's close to 50 years after the fact. The guy was still in great pain about the way that he performed. It's just remarkable.
As well he should have been. All right.
The rest of them went on to make money.
Third source of evidence are so-called natural experiments. As you should know, if somebody says there's a natural experiment, you know two things. One, it's not an experiment, and two, it's almost surely not natural. Okay. Basically, the idea here of what are called natural experiments is to look at environments in which there's been a change in social structure that is sufficiently large that it would swamp all the other sources of the outcome, and so that you can make a claim. one example of these natural experiments that's got a lot of attention are cases where there have been programs which essentially either provide, in the case of moving to opportunity, it was actually run as an experiment to see whether or not if you give families incentives to move to low poverty neighborhoods, what happened to the families. Okay, the data sets for that have been expanded. In fact, Nate Hendren has a major paper, I don't know if he talked about it recently about it. All I want to say about the moving to opportunity is that the history of it's very strange. In other words, the first generation of studies of the effects of giving these vouchers to families didn't find very much. Okay. The Hendren et al. Work, the difference is they were able to look at the children and what happened to them as adults. Now the thing that's surprising and a mystery in all this is that if you actually look at where the families moved in moving to opportunity, they didn't move very far. So in other words, it was relatively short distances. And so it's not clear at this point exactly what's going on. So in other words, there's a heterogeneity in the results. The most recent results, which have to do with the children, are quite suggestive, but I think there's still questions just to understand what the mechanisms were. But that's really one example. Another example is the US Army. Now you might say, why would I list the US Army as a natural experiment? If I said name one institution, which institution in the United States is unusual because it has the most integrated leadership structure of any American institution, and also has very specific rules for punishment of discriminatory behavior. Oddly enough, there is one. It's called the US Army. And so a number of sociologists, including the late Charles Moskos and John Sibley Butler, have studied the effects of participation in the Army environment on individuals, black and white, and how they think about the world. And it's extremely interesting because you have individuals, in this case, obviously there's a self-selection issue. I'm not saying this was an experiment. Is that you see that people who've experienced very different environments in terms of the interactions of African Americans and whites have different views ex post. And so again, that's very suggestive of how experiences can qualitatively change how people think about the world. And so I mention this, by the way, not just because it's a cute example. These data have been understudied. Okay, the US military has spent so much money that any IRB would let them do anything. In other words, vast amounts of money to understand things such as unit cohesion and how to create solidarity amongst soldiers. And one of the major issues in the United States military is how to bridge issues of conflict, hostility, differences between ethnic groups. There's massive amounts of data that were collected by the US military on specific things such as the ethnic composition of battalions, the black-white mixes, and the consequences for how they function. And so if somebody was enterprising, those are data that I believe can be obtained. And I know that some sociologists in the past have done it. So I think that's a very interesting open area. All right, final area is going to be the following, and that is regression analysis, what we know and love. And so what I want to say is that there's, we could stack the room with papers that run regressions looking for social interaction effects. And the canonical models, I'm going to talk in a linear way because that's easier, but there's nonlinear analogs, discrete choice, blah, 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 which you have some outcome, and it depends on two types of variables. One type of variable is, and this is what I meant about the index, it's individual indexed. I'm affected by my father, I'm affected by my mother, so on and so forth. Those are X's. You then introduce some other variables that are measures of kind of the social environment that I'm in. It could be the fraction of college graduates amongst the adults in the community I grew up. It could be the average income of the community I grew up in, so on and so forth. And what the literature does is it interprets, I should have said social interaction or social effect, as asking conditional and controlling for the individual indexed heterogeneity. Is there something about the more aggregated heterogeneity that has marginal explanatory power? And so this is the canonical question in the empirical literature, is to run regressions or linear or statistical models of that type and say, conditioning on observable individual level heterogeneity, does observable group level heterogeneity tell us something in the statistical significance sense? So.
I spoke about the Glaser, Sacerdote, and Schenkman paper, and that is exactly what that paper is about. You said it actually better than I did, so I won't lecture anymore. but that's,
I really augmented what you said.
Yeah, but that's exactly the point, right? To look how individual heterogeneity is, what they do is look at how individual heterogeneity is magnified by the social interaction effects.
So what I want to say about the regression literature is not terribly complimentary. I guess the first thing I would say is that you want to find studies of social interactions, there are many of them. However, there's some general conceptual problems with the literature that you need to be aware of. But these are, problems are also things to work on. One of the problems is that there isn't any clarity as to what group level variables, what social variables to include. So I could have a paper that says put in average income of the neighborhood. Another paper puts in the fraction of families on public assistance in the neighborhood. A third family puts in the fraction of amongst adults in the community of college graduates, so on and so forth. In other words, what is missing in the literature is a principled way of developing empirical analogs to the social interactions effects. Now that sounds kind of odd because after all, we say, oh, we have all these mathematical models of social interactions, but those mathematical models do not lead to empirical measurable analogs. So if I say that individuals draw inferences from the income distribution, the joint income distribution and educational distribution of people they observe, does everyone understand what I mean by that? So I'm a high school student. Just like all of you, I rationally calculated when I was a senior in high school the cost benefits to going to college. So there was an expected value to going to college in terms of future income streams, and there was a cost to going to college. And I, of course, compared the two. You're supposed to be laughing at this, all right. Obviously the wrong audience. Okay, so the point is the following, and that is one of the things to think about in what segregation does is it isolates adolescents into communities where they do not see individuals who went to college and did well economically. Economic segregation tautologically means they don't see people who did well economically. Therefore, they aren't observing the payoffs that they would experience were they to go to college. Now, if somebody taught them the Heckman selection correction, maybe they could account for it. But the serious point, of course, is that such segregation does is it alters the environments in which people form beliefs. And it does not about rational expectations or not, or very specific assumptions about belief formation. It's the statement that the information sets are segregated, and that has consequences for the formation of expectations about the future, as well as something economists do not have a good language for called aspirations. All right, and so it is a very big deal that even though I could write down a mathematical model of how segregation affects my inferences, it doesn't tell me what to put in the regression. That was what I was trying to say, please.
Yeah, and so on this point, materials best capture group effects, since we think that the major determinants of identity in terms of group identity may vary across contexts, could it be useful in a given context to use, assuming we have lots of covariates, a machine learning type approach to try classifying people into groups that are like, to understand what, obviously we need to have it be on a relevant dimension, what we're grading their life on. But that might give us some structure to think about without us having to impose from outside what we, the social scientists, imagine must be relevant.
I think it's a very promising idea, but not. I'm always. That's the easiest answer in the world. I think it sounds like a great idea, but I don't. We'd have to have a longer conversation where I could defend the position. So I think it's a promising idea. Let me leave it at that. Okay. But is everyone clear on this point? That as rigorous as the theory might be, it does not translate naturally into empirical analogs. And that's something that has to be accounted for, and something we actually need better theories of. Now, this is hardly an original problem in social interactions. However, there's much more advanced work in other areas. So if you look at the literature on socio-emotional skills, personality, non-cognitive skills, the conceptualization there is of measurement systems. We have observables, and they are functions of the things we care about, and there's a certain process of engaging in signal extraction. Those techniques have not been applied here, and they clearly are just as important. And so I put that on the table. Yours is a much more sophisticated way of doing it, but there's just an idea there that I think warrants pursuit. Okay. Third comment I want to make is that the econometrics literature has been very concerned about distinguishing whether or not your characteristics affect me versus your behaviors. The regression literature hasn't. In other words, it has not distinguished between so-called endogenous social interaction effects versus contextual social interactions effects. And so that's missing. The final comment I want to make is that very little is actually known about the microstructures. And I'm going to modify this a little bit and tout a paper that Raji Jayaraman, Buzz Brock, Larry, and I published in the JPE 2 years ago. And that is, if you look at the way the empirical literature works on social interactions, what's it mean to run that regression? That regression, and I'm going to now be a little bit more concrete. The most common regression in the literature is called the linear and means model. My outcome depends on my parents' education and the average education of parents. It depended on my parents' income and the average income of parents, so on and so forth. Those types of models have made a remark. Think about what assumption is being made there. It assumes a particular social structure. In other words, it says that the social structure is literally block diagonal. If you're in this group, you only interact with each other and nobody else. Furthermore, in each group, you take an unweighted average of everybody else. No best friends, nobody you don't much like, so on and so forth. And so what is a curiosity in the econometrics literature is that the identification questions are formulated in the form, assume you know the social structure, you the analyst. What can you identify about the respective role of individual characteristics, endogenous social characteristics, and contextual social characteristics? Whereas the position we took is, you shouldn't assume you know the social structure. Now and so it turns out there's constructive answers to that, but I want to say we just began to flesh out the assumptions possibilities frontier, so I put that on the table as a general area worth thinking about. All right? And so I'm calling these kind of these are the background areas that need more methodological research. So, that said, what the literature itself does, and I think I someday will learn how to spell classical, okay, is that if you look at the econometrics literature, there are really three problems. One of them is the classical identification problem. When you learned simultaneous equations, what was the problem? You have to ask, I have endogenous variables, regressant endogenous variables, I need instruments for them. I somehow have to figure out whether or not I can uncover in the system the role of the exogenous variables versus the endogenous variables. That's all simultaneous equations are trying to address, right? That same problem comes up here. Because after all, if I say I'm in a social interactions neighborhood, you depend on her, she depends on her, so on and so forth. Those are the endogenous effects, and I want to distinguish those effects from whether or not your education affected you, so on and so forth. And so many of the identification problems in the social interactions literature are simply restatements of classical identification problems. And then what's called the reflection problem, named by Chuck Mansky, is simultaneous equations identification. The second issue in the literature is self-selection, and that is that social structure is endogenous. In other words, we have to account for that in the regression. All right, so if I said to you, here's an observation. I used to live in Palo Alto, California. Palo Alto has a set of extremely run-down apartment buildings. They're horrible. They have incredibly high rents. And who lives there? The people who should live there are graduate students, ha ha ha. But seriously, you want to know who lives there, of course, are immigrants. So you have families that are paying very high fractions of their income, 70% of their monthly income to live in these apartment buildings, which are all awful. Why are they doing it? To be in Palo Alto's schools. So if I were to look at the effect of Palo Alto's schools on individuals, on poor people, I would have to account for something, wouldn't I? The self-selection of particular types of parents into the Palo Alto School District. That's self-selection. The answer that I want to give, and Larry and I give in joint work, is if you're in an environment with self-selection, model it. In other words, if self-selection clearly affects inferences. We've known that forever. The constructive solution to self-selection is to expand the model to account for the self-selection. That's what a selection correction does. That's the classic Heckman selection correction, or what in modern versions are called control functions. And so the answer I would like to put on the table conceptually is that in environments with self-selection, the model needs to be expanded. It's not a good enough model. It's too thin. The other problem is the one that I personally think is the hardest one in social interactions work, and that's the problem of correlated unobservables. Suppose I looked across, everyone with me? So I look across classrooms. All the students are doing well in this classroom. All the students are doing badly in this classroom. Well in this classroom, sorry, badly in this classroom. Well in this classroom, so on and so forth. And that's fact number one. Fact number two, the classrooms have identical distributions of parental characteristics. Okay, exact same income distribution, exact same occupational distribution, exact same educational distribution. Everyone with me? Do I get to say, wow, social interactions, good classroom, all of that high effort is being reinforced because of peer effects? Sorry, low classroom, they're all screwing around, reinforced. That would explain it, wouldn't it? In other words, social interactions could explain why one classroom with given socioeconomic characteristics students do well on average, another one does poorly. That's a perfectly reasonable explanation. The problem is there's another explanation. That's called teacher quality. In other words, it might be this classroom had a good teacher, this one had a bad teacher. Teacher quality, that's an example of a correlated unobservable. Every student's affected by the same shock. And so the other issue in thinking about the identification problem is the assumptions we make about is the nature of the heterogeneity. We like to think about things being independent across the observations. Well, if it's a social context, and we think the individual behaviors are interdependent, how could the shocks not be interdependent? But once you have interdependent shocks, there's a separate identification problem. Now, this, as I said, in my opinion, is the hardest problem in this literature. The reason for that is that when I talk about self-selection, I'm talking about a behavior. That's what social scientists model. That's what we do for a living. And so we have a logic in our toolkit. We can disagree on which logic to pull out, but we have a logic in our toolkit to address it. If I just say there's correlation in the unobserved heterogeneity, there's no economics there, there's no social science there. And as a result, we need statistical tricks to do that. And so that makes it a much harder problem in my judgment. All right, so let me just talk through very quickly an example. And I know I'm supposed to take a break. I'm going to take it at 2:45, I think, if that's okay. If it's not, I'm the dictator in this. All right, so here's a way to think about problems. Okay, so I want to make this very concrete. Suppose I made an observation that there's a negative correlation between the probability of graduating from college and the poverty rate in a neighborhood. So in other words, poor neighborhoods, kids tend not to graduate from high school. How would we explain that? Is it a statement that poverty the poor neighborhoods adversely affect kids or not? That's the mechanism. So one explanation, again, I'm not endorsing any of these, and not meant, to be, they're meant for illustrative purposes. One thing is I could say that a poor neighborhood is concentrated with people that were not particularly, they had low labor market aspirations for whatever reason. And if parents transmit those labor market aspirations to their children, then the children aren't going to go to high school, or are less likely to graduate from high school. Again, I'm not endorsing that, but that is not logically impossible, is it? Or I could say a poor neighborhood is made up of people who miscalculated the value of a high school graduation, and so that miscalculation gets transmitted from parent to child. If this were true, then it would be the case that you would have a negative relationship between the poverty rate and the high school graduation rate. It would not be a social relationship. It would be entirely due to the aggregation of different types of people in the neighborhood. Okay, so that's an example where self-selection would be a big deal. Here's another example. And notice these things about the families that cut in more than one way. I could say a poor neighborhood is made up of adults who can't afford to send their kids to college. Therefore, the value of the high school education is diminished for their offspring, and thence we get the same relationship. All right, again, that's a self-selection explanation. Here's another one. Teacher quality is lower in high poverty neighborhoods. In other words, high poverty neighborhoods are more likely to be in school districts that are facing financial constraints because of the local generation of revenues. Okay. That gets to the question as to what a social explanation is, and this is your political economy question. So the political economy of educational finance could induce social interaction effects. In other words, the local public finance of education in the United States, which still generates about 40% of revenues at the local level, creates a mapping from the local income distribution to educational quality. Here's another explanation. I gave you this one before. Poor neighborhoods are going to have relatively high concentrations of individuals who, even though they graduated from high school, did not do well in the labor market, or graduated from college and didn't do well. That's what it means to call it a poor neighborhood. Therefore, the inferences, the beliefs, the aspirations that formed amongst adolescents are affected by the segregation because of information sets. Okay. That's a social factor working through beliefs. Here's another one. Teenagers form aspirations. They form identities. If they grow up in a neighborhood where adults didn't go to college, that doesn't become part of the aspiration set. That's the identity argument. And so segregation alters the identities of the individuals in the neighborhood, which alters the educational outcomes. Yet here's another one, was local public finance. And then the final one, which I mentioned before, it would be that there's peer effects. And so in other words, in some neighborhoods, there's this virtuous circle of high educational attainment reinforced. Other neighborhoods, a vicious circle. Okay. So if you put them together, each one of those stories, I would say each one of the mechanisms I described gave the same relationship. The question in econometrics is if I write down a formal statistical model that instantiates these different mechanisms, can I tell them apart, given the data that I have available? Okay. And so what I wanted you to see is that that's going, this is going to require some hard thinking. There's many affirmative answers, constructive answers, but it takes some work. All right. So let me just end before the break with a couple of comments about public policy. The first is that I think that one of the important implications of the social interactions literature is that in thinking about redistributive policies, we need to kind of expand the domain of what redistributive policies are. And what I mean by that is that we want to think about that thinking about is not endorsed. I'm not saying you should agree about the specifics, but rather a thing to think about is whether or not we can engage in something I've called in my writing associational redistribution, which is a horrible phrase, but the point is that it's saying that maybe what you can redistribute are memberships, or so you can alter social structure through policy. Now, what I mean by that is that if you think about different policies in the United States, this isn't some weird Orwellian thing. Government policy does this all the time. Okay, this is just back on the table with the recent Department of Justice statement, thinking about affirmative action. Affirmative action, in my mind, is nothing more than saying, here are the rules we're going to set for the matching of individuals to slots in schools or to slots in firms. There's a plethora of different rules to do that matching, and what's called affirmative action is a specific class of policies in contradistinction to another class. All right, and so one can think about affirmative action as what I call associational redistribution. It's saying that if you do things one way, this is what the distributional consequence is for the matches. You do something a different way, you get a different match, nothing more than that. Something that was done in the 1960s, 70s, 80s, and still has some residuals today was busing for integration in American schools. So in response to the ending of de jure segregation in the United States, many school districts had court decisions which mandated the integration of the schools. So this is more political economy for you. All right, so in other words, you have, and this is, by the way, an enormous natural experiment, which was interventions to alter the allocation of students across schools to facilitate integration. These data have been available. They have not been studied using modern techniques of either econometrics or social interactions analysis. I think that that's something well worth studying because this was a very wide, large-scale intervention. Relative to your question, there's a very interesting point here to know about the political economy, and that is the way that these school decisions worked for busing is they were always within a school district. And so, roughly speaking, what a court would say is this school district had a history in which the government promoted residential segregation. The remedy to it was to integrate the schools within the school district. That was a limited thing because what then would happen is that families would leave the school districts. And so there's some reason to believe that the policy partially unwound because families wanted to be segregated socioeconomically or racially and left the districts. So again, you have to talk about the political economy if you want to know the consequence of the policy. All right. At a lower level, charter schools and magnet schools are also ways in which you alter the associations for individuals. They facilitate ways for families to isolate their kids or to choose the peer effects that they have. So I put all of those on the table. And I think that these are things that require, that if you take the social interaction stuff seriously, as empirically salient, that you have to think about policies that do alter social interactions. Now, I think that there's kind of three things I want to say here. The first is, there's some complicated normative literature on these things. It doesn't mean that it's problematic, but in thinking this stuff through, one has to be careful in defining equality of opportunity and figuring out how different associational policies meet one's equality of opportunity objective. So put differently, where the action is in political philosophy, particularly where economists spill over into philosophy, is developing principled arguments for equality of opportunity as distinct from equality of outcomes, in which something called responsibility-sensitive egalitarianism, which is a mouthful, which says is that we want to think about equality as we equalize things when people aren't responsible for them, for the differences. They're responsible, then we respect agency. And so one can justify the policies doing that. It's a little bit tricky. A second thing to think about is your question again, political feasibility. In other words, these policies have not proven to necessarily be efficacious in the long run. And the third is to think about what Glenn Loury has called supply-side approaches. Okay, so what's the difference? In the U.S. Army, there is a continuing issue that the promotion rates for black soldiers are lower than white soldiers. All right, so the way the Army has addressed it is not to set, and it's fairly regimented in terms of test scores and things. What the Army has done is to basically have some mechanical rule for promotion, but by studying why there are differentials in the test score grades, they create educational opportunities that people can take to equalize. Does everyone see the distinction I'm trying to draw? If I observe that two groups have different success rates on tests, and then I make the observation, there's a reason for that this one group, they went to lousy high schools. And so what the Army would do is offer additional writing programs. And so that's a supply side in which is trying to alter the distribution of the test scores across the groups and minimize the gap as opposed to doing something ex post. So it's just a different way to think about affirmative action. I just put that on the table to think about. Final comment I want to make is that these are highly nonlinear systems. And so in doing cost-benefit analysis, one has to think about that. Suppose I had a fixed amount of money and my choice is either to offer 10 scholarships to 100 schools or 1,000 scholarships to one school. Everyone with me? Well, what should I do? Well, it sounds like 10 for each school sounds fair, doesn't it? Because we have a presumption of equal treatment. On the other hand, if there's social interaction effects, if I go to the school and give everybody, I suppose there's only 1,000 students in the school, and offer everybody a scholarship, he goes to school, that spills over onto her, she's more likely to go to school, spills over on him, so on and so forth. What happens because of the nonlinearities is the bunching of the resources will scale beyond what you would have seen if you had spread things out more thinly. And so that tells us two things. One, many of the analyses of programs, if there are social interactions effects, and you don't find much of an effect of the program, maybe the answer is to increase the program, not decrease it. It's because if you increase it, you take advantage of the social interaction effects. Second, there's going to be equity efficiency issues that arise. Okay, so let me take a 15-minute break, and then I will get back to more details. Okay, so why don't we get started? What I'd like to do is to get into a little bit more technical detail, hopefully with some payoffs in terms of substantive insights. So in the theory, what I wanted to do was simply to focus on this idea of complementarity a bit, and that is to flesh out this idea that a fundamental assumption in the social interactions literature has to do with the way in which social influences map into preferences or into constraints or into beliefs, and that's the idea of complementarity. The way that I want to do that is to work through a very simple model. It's actually it's an oldie but a goodie due to Russell Cooper and Andrew John, which is it's about the simplest model I know of modeling complementarities, I think, in a way that's clarifying. And so here's the thought experiment. You have a group of individuals indexed by I. There's a capital I of them, and they're making some effort choices in the interval 0, 1. And each person faces a payoff function. So the idea is that I get a payoff based on my effort and the average effort of others. And so that payoff function is V. I'm going to assume all the stuff that makes life easy for us. Nice smooth functions, differentiability, twice, no corner solutions, all of that stuff. There's a term for that in economics. It's called, those are uninteresting technical details, UTDs. They don't affect anything in terms of the underlying analysis, hence I make all of them. All right, so I have this environment. People are interdependent, and I'm going to summarize the interdependencies through their payoff functions. How would I think about those interdependencies then? Well, the key to understanding the analysis is this idea of complementarity. And the way that one algebraically expresses complementarity is to say that the cross-partial derivative of my effort with respect to your effort is positive. All right, so it's just this nice, this second derivative. Okay. Now here's something to notice. As far as everybody understands what the condition is. Now what is a cross-partial? It's the derivative of a derivative. So one way to say it is the derivative of my payoff with respect to my effort level is increasing in the effort level of others. Does everyone say that's what the cross-partial means? And now we have the keys to the intuition. That cross-partial condition says that my marginal payoff is increasing in the level of what other people do. That's what creates correlation in behavior. If other people do a lot of something, it makes my marginal product higher than otherwise. Well, if my marginal product's higher, I do more of it. All right? And so a way to understand these models is that if I said to you that my payoff is increasing in what you do, that's a statement about my welfare, my utility. I was doing normative analysis, we would account for those things. But if I want to, and that's a type of interdependence that matters. That's called a positive spillover. Now it is the case that if the LA Dodgers win the World Series, my utility will go up. However, I also can assure you that no behavior of mine will be affected by whether or not the Dodgers will win the World Series. If we're interested in the behavioral consequences of social interactions, we don't care about it's not the level effects. It's the optimality conditions for behavior, the first order conditions. Now what are first order conditions? They're in a very sophisticated way, all first order conditions are the equating of marginal costs and marginal benefits. And so complementarity says that the gap between marginal benefit and marginal cost is increasing in the level of the other agents. That's what is driving the entire environment. Okay, so everyone see a very simple intuition has an algebraic instantiation, and that lets us work things out. All right, so that's the reason why that condition is ubiquitous, shows up over and over again. It's because it says something about the way in which social interactions work. Now, here's an algebraic trick, which is if I integrate a positive function over two intervals, I always get a positive number, don't I? That's a very big deal. Because it means the following. It says, first of all, that if you compare my doing a lot to doing a little, when others do a lot looks better compared to doing a lot versus doing a little when others do a little. That's the statement that complementarity induces correlated behavior. Here's the second point. Suppose I went to this condition here, and I had the option of having I could have A and B in one group and C and D, the low values in the other. I'm sorry, how did I do the integral? I could have A and C here and B and D, put them over here. What would be the net effect of doing that versus integrating them? What this says is I'd rather have the high ones here and the low ones here versus mixing them, because the net product of the highs together and the lows together is positive. It's the same set of conditions. That's a hint about integration, isn't it? If firms have workers of different skill levels, what will competitive incentives do? They'll put the high-skilled workers together in one firm, the low-skilled workers in another firm, when they're complementarities. So all I'm saying is that if you think about this cross-partial and you just integrate across it, it has a bunch of information embedded in it. One is answering the question, would I rather have the two high values together and the two lower values, or would I like to mix them? The second is, what is the consequence of high behavior by others on an individual? All right, so that's the critical idea. Now, is everyone comfortable with this idea? Complementarity begets correlated incentives, and creates incentives for correlated behavior. And implicit in complementarity was something about the consequences of matching the highs together versus matching the lows as opposed to integrating them. In any model, of course, it is not sufficient to say these are the individual incentives. I have to say something else. I have to talk about what I call the adjudication of the interdependencies. That's the equilibrium solution concept. And so in this world, there's a question, do people cooperate or not? So one thing I could do is I could say a bunch of people are choosing effort levels. Then they don't coordinate, they don't cooperate. And so each person makes the choice of an optimal effort level given what other people do. Okay, that's the Nash equilibrium concept. And so since everybody's identical in this model, I can restrict myself to symmetric Nash equilibria. And so a non-cooperative equilibrium is some common effort level such that everybody is individually optimizing. What does it mean to optimize? Marginal product equals marginal cost. In other words, marginal payoff to increasing effort level is 0. That's the first order condition there. Everyone with me? Second idea, what if we cooperated? Since we're identical, the way we would cooperate in this world is we agree to a common effort level. That would be the second condition, and that is the marginal product of each individual with respect to his or her own effort, plus the marginal payoff to everybody from the social effort, the E bar I, the sum equals 0. Okay, that's a cooperative equilibrium. Notice a cooperative equilibrium presupposes we can commit to working hard. After all, if the sum of these is 0 and that's always positive, that's a positive spillover, what does this have to be? It has to be negative. And so the message is the following. In these worlds with complementarities, there's going to be an intuition that says that when people cooperate, they're going to do more of the activity than if they don't. And the reason is that we each would have see, what I would really like is not to work very hard, and you all work hard because I get the big positive spillover, but the cooperation is we all make a joint decision. Okay, so there's a message there that if you look at the equilibria in the cooperative and non-cooperative cases, you often see more extreme behavior in the cooperative cases. Please.
Do you see a mechanism that could possibly create the cooperative equilibrium, since we tend to see a Nash equilibrium instead?
Well, I think that we have to be, everything depends on context. And so what I would say is that in a two-person co-authorship team, we can get the cooperative equilibrium, right? If it's a matter of the type of fashions that people wear, it's very hard to think about a cooperative equilibrium. And so that's a cheap answer. The more sophisticated answer is to then understand things such as how do social norms emerge? And in fact, you think about Ken Dory, many papers which have talked in evolutionary game theory and social norms have asked these questions is about when can the norms emerge as equilibria. Now, Larry, am I misstating something? Okay, good. See, it's good to have a game theorist in the room. Keep me honest. And so again, but the answer I want to give is everything is going to be, we have to set up the environment, specify the context in a way where we can, first of all, decide a priori which sort of assumptions we want to make about information and the like. And then second, we can ask about what would a norm be defined as in this group. And if you think about the way these models are going to work, it has to be relatively inexpensive for people to enforce the norm, but very costly not to enforce the norm, just as it has to be costly to violate the norm. And that's going to be the trick in these types of models. Please.
This is making me think a bit of the Hallhouse example we talked about and the reference to U.S. Army's interest in understanding group dynamics. If soldiers were to feel a pressure to be complicit in atrocities or to not report one another's, violation of international law, let's say, would you see that more as their preferences have been changed through some process of group formation, or rather that they see some incentive that they're going to be hit with, disapproval or rejection by the group, if they were to take the anti-group action?
That's a very hard question. I think we'd have to, again, talk about the historical context. So if you take an individual atrocity, there's clearly enormous social pressure. But in the case of studies of particular battalions in the Second World War that committed genocidal things, I'd say the surprise there was the lack of retaliation if you refused to participate. So that's off lecture, but I can tell you the references one-on-one. All right, so back to this. What I want to say is that is the following, and that's really all I want on the table. In other words, if we think about the model, it's really very simple. I should have included a slide that said this. The non-cooperative equilibrium implicitly says the following. If I tell you the average effort of others, I know how hard you're going to work. That gives me a best response function. Everybody has the same best response function. Therefore, An equilibrium is an intersection of the best response function with the 45-degree line. Okay? So we can see visually what these equilibria look like. Now the question I put to you is, what determines whether a best response function is upward sloping or downward sloping? Well, remember, I have all the nice conditions, concavity and all that good stuff for the payoff functions. What's key then is complementarity. Complementarity said that if others do more, my marginal product is increased. Hence, my best response function is higher. And so what complementarity is really doing in this model is it's controlling whether there's an upward or a downward slope to the best response function. Now, if you think about that for a second, am I really there? Oh, there we go. What would multiple equilibria represent? Multiple equilibria require multiple intersections of the best response function with a 45-degree line. Can a downward sloping function ever intersect the 45-degree line more than once? No. So there's a result. A necessary condition in this model for multiple equilibria is the presence of complementarity. Is it sufficient? No. Here's an upward sloping function that intersects the 45-degree line once. Here's an upward sloping function that we all know and love that intersects it 3 times. The key is this one intersected at the slope less than 1, and it never gets back. This one intercepted greater than 1. Okay, that's algebra. What's the idea? There has to be a range where the complementarity has a strong enough effect on behaviors so that you can get multiple self-consistent bunching. That was the phase transition story I told you about. Exactly the same thing happens here. If you start off with a model with no complementarity, and you just introduce a little tiny bit here, you can still get a unique equilibrium, but if it becomes strong enough, you get multiple self-consistent solutions. Okay, nothing beyond that. So that's really all I wanted to say about complementarity. Just very simple intuitions. Number 1, it changes first order conditions. That's why it can change the equilibrium behaviors. 2, in these particular environments, it becomes a necessary condition for multiple equilibria, not sufficient because it depends on how strong it is. And 3, we can differentiate the behaviors in the non-cooperative and cooperative worlds in terms of the magnitudes, where the coordination itself actually can lead to stronger behaviors than otherwise. Please.
So I think it's worthwhile mentioning that you get this story because of the nature of the function G. So to give and so here what happens is that as the complementarities become big enough, you move from the phase transition that you were referring to earlier is from a regime of a unique equilibrium to a regime of multiple equilibrium.
Yes, exactly.
If you look at a game like this doesn't happen in the quadratic game that we looked at on Tuesday morning that I put up on the board, where we're looking at conformity effects in quadratic distance. There's a paper by Yves Zanou and Eleonora Patachini which estimates peer effects in a classroom that appeared in the Review of Economic Studies. And it too is a quadratic game, but it sees the peer effects as being a complementarity in learning, okay? And it is a quadratic model, and here you see a different kind of phase transition. And so it's worth pointing out that you have to watch your functional forms to get this right. What happens is that they have a unique equilibrium where the peer effects matter, and the peer effects matter here, even in the unique equilibrium, by the way. But in their model, there is a peer effect, and as the peer effect gets bigger, ultimately what happens is that the you go from a unique equilibrium to having no equilibrium at all. Okay, so there are a variety of different things that can happen depending upon how you specify the model. So you need to choose the right class of functional forms to get the kind of phenomena that you are looking for. That's it.
Okay, thank you. So that's big idea number 1, is that complementarity, interdependences, multiple versus unique equilibria, and the like. Second big idea is assortative matching. And this is the famous Becker marriage model. So here's the thought. So the idea, in other words, is, remember I made a claim in the first part of the lectures. I said there's 2 ideas that we're going to emphasize over and over again. One of them is social interactions imply complementarities, and that begets multiple equilibria social multipliers. And so I just gave you a simple example of that. The second was social interactions and complementarities beget segregation. And that's the second idea. So let me describe, for those of you that don't know it, this extremely romantic model of life. Okay, so this is the Becker marriage model. And the idea in the Becker marriage model was to say the following, and that is that there are N men and N women, and each man and each woman have a characteristic, a scalar quality in the paper. And the idea is that a marriage is a match, and it produces, with this capital phi, some output, M and there's a function of the attribute of the men and the attribute of the woman. And so Becker's question is who marries who? All right, so as I said, I've made fun of the model, but the point of the model was twofold. One, it had a substantive point, which is he wanted to explain the observed patterns of a sort of mating, marriage, by education. The second thing is it turns out that the mathematics of the model is going to apply to many different contexts. Okay, so is everybody with me? You have two types of individuals. You're matching them pairwise. And the question is, which configuration of matches maximizes the total product of these matches? Okay, I could say it's for, so there's this mysterious thing the marriages produce here. I could have said it was firms. You have workers that are white collar and blue collar and matching them up by their skill levels. Which configuration of skill levels of the different worker types maximizes total output? It's exactly the same problem mathematically, isn't it? And it doesn't sound quite as odd as saying it's a marriage. So what Becker showed was the following, and that is, in the Becker marriage model, if that marital production function has a second derivative that's positive, then assortative matching maximizes the sum of products across the marriages. In other words, I would take the highest W and the highest M, that's marriage 1. The second highest W, the second highest M is marriage 2, so on and so forth. If you configure individuals that way, that maximizes the sum of the marriage outputs. It's mathematically the same thing as saying that if I look at the skills of blue collar and white collar workers, the way that I would maximize total output of the firms, you take the highest skilled ones, you put them in the first firm, the second highest skilled in the second firm, so on and so forth. Everything is driven by that complementarity condition. Now, we already proved the Becker model. Remember when I took that integral? That's the proof in Becker's paper. Because that thing is positive and you integrate across it, you manipulate it, and that says this has to be efficient. All right, now that's a very interesting point because it says something that's quite, and so that's the proof once again. Okay. Now, this is what I want on the table. The first thing I said is here's a classic result in economics, a very influential paper that said when there's complementarity in the characteristics of individuals, efficiency says that you should segregate. Now notice that begs the question, is efficiency the equilibrium? Everybody with me? So what would it mean to talk about an equilibrium in a marriage market? Well, there's different ways to think about it, and one of them, the classic, a standard way, is to think about marriages as cases of so-called transferable utility. What that means is that whatever it is the marriage produces, there's some other commodity that the partners in the marriage can exchange. And so that leads to a theory of intramarital bargaining, for example. Let me not talk about that, but give you the simplest example. Suppose that this was not a marriage, but a firm. Everybody with me? And so there's two types of workers. Those are simply the skill levels of the workers. Suppose that it were the case that the function was, was nice and smooth. Everybody with me? And everybody is paid the marginal product of the skill. Then the market equilibrium would be exactly the same thing. That is the efficient equilibrium in terms of maximizing total output. Similarly, but notice that in a firm, the way we think about it is the output of the firm is divisible, and hence we can pay marginal products. When the output of the firm is indivisible, as in whatever it is a marriage produces, that's why you have to have this thing called transferable utility to mimic what I just described. So those are technical tricks. Here's the point I want on the table. Okay, first of all, is everybody comfortable with the idea of the Becker marriage model? I was asking this question, who's going to end up with who when you have these different skill levels? I gave you the example that if there's positive cross products in the skill levels, you can see the market incentives are you pay more, the firms will pay more to people who have high skills. That exhausts the product, that becomes firm one, so on and so forth. That same thing will occur if there's an indivisible object and there's transferable utility. All right. Now, why is this an important idea? I had this wonderful thing I wanted to say, and I don't say it here. Okay, I'll have to say it verbally. Before I go on, does everybody understand the logic of the model? It's very simple. I want to ask you a question about inequality now. Suppose I have an environment in which agents receive marginal products. Everybody with me? So I want to be the nice, smooth, firm case. Notice neoclassical pricing. That's assumption number one. Assumption number two, there's complementarities. Of every possible configuration of partners across marriages or workers across firms, which one is inequality maximizing? Does everyone understand the question? I could assign workers across firms any way I want. I want to know which configuration maximizes the gap between the product of the most productive firm and the least productive firm. Same question. Which one maximizes the gap in the product of the highest producing marriage and the lowest producing marriage? That sounds like the one that maximizes intergenerational persistence. Of all of those configurations, which one does it? A sort of matching, the equilibrium. Okay, so you must say this model lives out everything. No, it has the essential thing in there. Because the objective of the model is to understand something, and that is the incentives for segregation. What I want you to see is the incentives for segregation, which are at a micro level, individual level, have a collective consequence. That of all the configurations, the one that's inequality maximizing turns out to be the equilibrium one. Okay, and that tells us something very important about the so-called equity efficiency trade-offs. Have people heard that term? It was Arthur Oger coined it about over 50 years ago. And it's kind of a sloppy term. And the idea is, intuitively, is it may be that there's trade-offs between something we call efficiency and something we call equity. Now, the reason the term is sloppy is it begs the question as to what we mean by efficiency. To have efficiency, you have to have an objective function, some measure of efficiency. Similarly, for equity, you have to have a measure of equity. That said, Oken's idea was that some redistributive policies, tax policies, they may have efficiency consequences because they have incentive effects. What I want you to see here is this is a pure example of an equity efficiency trade-off. In other words, there really is something going on that's intrinsic to the logic of the environment. And that's even true under competitive factor pricing, so no market distortions. So, what I want on the table, as I said, idea number one, complementarity and multiple equilibria. That's what the Cooper-John model very quickly illustrates. All you have to do is draw a picture. Idea number two, complementarity and social interactions provide an insight into sources, reasons, mechanisms, that's the word I want, mechanisms for segregation. That's the Becker marriage model and associated generalizations. It turns out the logic of the Becker marriage model is very robust. In other words, if you have arbitrary numbers of agents per firm, you get exactly the same conditions. Complementarity is the key assumption in all of that. What I want to do, however, is at least give you an example of a case where the logic breaks down. And so I'm going to scandalize Larry by talking about our research. So as I said, the key, there's an idea in Becker, and that is a complementarity creates an incentive for segregation, and it's efficient. What Raji Jayaraman and Larry and I are working on are cases that shows that that's not true dynamically. And so the idea would be the following. Suppose I'm thinking about kids in classrooms. Everyone with me? And I said to you the classrooms exhibit complementarities. If I wanted to maximize the average test score next year, what would I do? If the inputs are their test scores this year, I would segregate the students by grade. No, by grade. If the classrooms are the same, I segregate by grade. If there's complementarity between teachers and students, it's even worse. I still segregate by their test scores going in, because I would pick the high ability students and stick them with the best teacher. That's now that's what I meant, that the assumption is I want to maximize the average. I don't care about the distribution. Okay. Now I could have an objective function that cared about something beyond the average. That's perfectly legitimate. The Becker result said I only care about the average. Okay, everybody with me? What Larry and I are working on is what happens if you think about a dynamic model. So the idea is you have test scores today, you sort the kids in the classrooms, that changes their human capital, there's new test scores, you resort them, so on and so forth. Is my objective when I have a bunch of first graders to maximize average second grade test scores? Well, that would be a weird thing to maximize, wouldn't it? Maybe if I don't care about equality intrinsically, I care about the average of 12th grade test scores. Those are the people that enter the labor force. So the upshot is, and this is what I want to put on the table, and this is what we're working on, is that dynamic models are very different. Because what you do in first grade is you're shaping the whole distribution that you get to work with in second grade. You get a new distribution in third grade. And if you do the shaping across time, it's only in the last period that you want to assortatively match. Much more complicated interior dynamics. Okay, and results to come. Get to work. All right. And so what I wanted to emphasize is the Becker results are very robust, but they're robust to static environments. When you go to dynamic environments, you need to think differently. So let me leave it at that. Okay, so that's what I wanted to say about the two basic ideas. What I want to now do is to just give you an example of a little bit more formal model. Okay, you will get these slides. I promise you they're fascinating. So what I wanted on the table, of course, as I said, were two ideas. Number one, complementarity, multiple equilibria. Two, complementarity, segregation. The instantiations are this game of effort that I described, and the Becker marriage model. Now let's see if we can sort of take these and put them together into a somewhat richer model that looks like an econometric specification. And so this is going to be the example. And that is, I want to think about individuals. Actually, let's do it right here. Okay, I have a population of people, and what they're going to do is they're going to make discrete choices. And there's L of these choices. Okay, everybody with me? So, I'm going to have some constraints set. They're unordered choices. And this is going to be the trick. Each individual has a payoff that depends on three things. If you make choice L, you have a term HIL. That's how much you personally value it. Okay, it's your utility indexed by your characteristics for school. That's going to be a function of your parents' education, so on and so forth. Then there's a second component, J times PILE. What is that? You get utility from the fraction of the people that make the same choice as you. And the third is the stuff you can't model. That's the epsilon. Okay. That's how we do discrete choice, isn't it? We'd say that I make one of L choices. Each of the L choices has a payoff, and by definition, I chose the thing that had the maximum payoff. What makes this social is I have the fraction of the population affecting the choice. All right? So, in doing multinomial analysis, we conventionally make functional form assumptions on the distribution of the unobserved heterogeneity. Notice, is everybody with me? I'm going very fast. I say that there's some distribution of H's. Those are the private incentives that people face. There's a social incentive. That's going to be the fraction of people who do the same thing. What does that make J? The complementarity parameter. Implicit in that is how what others do affects my marginal payoff. And then the third thing to close the model, so I can do algebra, is I'm going to make a choice of functional form for the errors. And so I'm going to make the multinomial logit assumption. And the reason to make that is it's easy to manipulate. Obviously, I don't believe in a principled way that this is truth with a capital T. This is a case where you make the modeling assumption because it facilitates calculations. Notice in this model, what does J measure? The intensity of the complementarity. What does H measure? The intensity of private incentives. What does beta measure? Beta measures the heterogeneity in the population. It has to do with the thickness of the tails of the errors in the multinomial logit. Now, unfortunately, it's a little bit irritating because if beta is really big, that means the tails are thin. If beta is small, the tails are fat. Now, I want you to, okay, so that, you see, so I want you to see, if I write down a model and say that the payoffs of each of the choices, they're going to depend on the private incentives, depend on social incentives, they're going to depend on the realizations of these epsilons, who we characterize via the density. And the density has a parameter that measures the thickness of the tails. Therefore, when I'm describing the equilibria, what's going to be determining the properties of the environment collectively, the distribution of private incentives, the intensity of the complementarity, and the nature of the heterogeneity. Is there thick tails or thin tails? Okay. And so and you can see, and if you think about it, that's what is the benefit of the algebra. It clarifies what's going to determine the equilibrium, and what the functional forms do is they're going to give us a functional relationship. Okay. So, if you go through that logic, again, by definition, my choice is the one that had the highest utility, the highest payoff. And so the probability that I made choice L, given what you know about my private incentives and my social incentives, is the probability that one had the highest utility. So if you crank out the algebra, you end up with this expression right here. And that's the multinomial logic. It says the probability that I do something is proportional to e to the payoff to that choice, is private, plus the social payoff, multiplied by beta. Right? Okay. By the way, if beta is 0, what happens? If beta were 0, the probability of every choice is equal for every person. Why would that be true? It would say that the tails were so thick for the unobserved heterogeneity that everybody's getting an epsilon draw for one of the choices that's astronomically bigger than the others, and so all the other incentives don't matter. That's why heterogeneity affects equilibria. In a linear model, if I increase the variance of the epsilon, it doesn't affect things, does it? Expected value doesn't change. In a discrete choice model, it does. The more heterogeneity, the thicker the tails, the less predictable individual behavior is via the stuff you've controlled for. So something to keep in mind.
Sorry, is this actually about predictability, or is it about the fact that your draw is going to be so distant from other people's that it wouldn't be...
No, it's so distant from my other choices. So the reason that Beethoven was a composer and Arrow was an economist is they got big draws for their epsilons. It didn't matter if they were in a world where nobody else did the same thing. That's the point I want on the table. So I seem to have screwed up the order of the paper. So what I mean, so this is what an equilibrium is in a model. So here's the first idea. Whatever your beliefs are, there's a certain probability you'll make each of the choices. All right? That's idea number one. Idea number two is to observe the probability you make a choice is a function of the fatness of those, the thickness of the epsilon tails. Okay, and because if they're very thick tails, then it's likely that one of your epsilons will control your decision. If for economists you get a big enough epsilon, it doesn't matter whether other people are economists. It doesn't matter what the deterministic private incentives are. That controls your decision. And so self-consistency is simply the statement. And equilibrium is people make the probability of the individual choices is such that at those individual choices, that's what people think will happen on average. So the probability of my subjective belief of the choice, which is PILE, has to equal PL. Everybody with me? What is the probability of what fraction of the population do I think is going to make choice L? Well, that's the expected value of the probabilities of each of the individuals. So I just integrate across the individual choice probabilities. And so what we have are a set of equations that describe equilibrium choice probabilities. So in other words, at these choice probabilities, those have to be the choice probabilities. Does everyone see the logic of that? I fix the choice probabilities for the population as a whole, choice by choice. If I plug those into the individual behaviors, they have to produce those same collective choice probabilities. And that's what equation 18 does. Yeah?
So we could use this statistical model to figure out whether or not there's complementarities or there's substitutabilities, right? So if we see that the J term is negative, then we would see that there weren't complementarities at all, correct?
There's one technical, there's not a UTD, an important detail, Because there were complementarities, I restricted myself to pure strategy equilibria. I assumed J was non-zero when I worked out the initial conditions. Okay, so that was an insightful observation, but there's a nuance to one has to control for. All right, you should love this equation. Actually, how many equations are there? There's L equations. There's a probability for the first choice 0 all the way to probability choice L minus 1. The probabilities of the choices, that's a vector of L objects, is a function of those same L objects. What do we like about exponentials among many things? They're smooth. Where do probabilities live? Between 0 and 1. Somewhere in your minds, fixed points, mapping vectors in Euclidean space with a continuous function into a hypercube. That sounds like Brouwer, doesn't it? Brouwer fixed point theorem. So they're all traumatized by general equilibrium theory. All right, the serious point is it's a triviality to say there's an equilibrium here. Okay. An equilibrium is just a set of choice probabilities for the population as a whole. At those choice probabilities, individuals will make choices that create those choice probabilities. That's all.
If only we still taught fixed points.
They're making a comeback at a very low frequency. All right, so you see how, so again, use very elementary techniques, and I wrote down a model of the social interactions of discrete choice. Could prove, its equilibrium immediately adheres. And we had an idea. The idea was that if I told you the distribution of the private incentives, I told you the strength of the complementarities, and I told you the beta that indexes the thickness of the tails, I should be able to say everything I need to know about the model. So my question is, how many equilibria are there? Now and the way I'm going to answer that is by simplifying the model. I'm going to set all the h's equal to 0. What's that mean? It means that I'm going to say that the thing that differentiates a choice for you or for me is the fraction of people that do it and our idiosyncratic unobserved term epsilon. Okay. By doing it this way, life just becomes very simple for us. By the way, if J were 0, what would the equilibrium be for the model? Okay, there's no differences in the h's. If J is 0, then the way it works is everybody gets a draw for the epsilon for the 0th choice, the epsilon for the first choice, so on and so forth. And he or she chooses what? The one that is biggest. Since every epsilon has the same density, what's the probability choice 0 is your choice? 1 divided by L, the same as probability 2, 3, 4. So in other words, if there are no social interactions, I know the solution of the model. The probability of every choice is 1 divided by L. It's a purely random choice. Does everyone see that? Okay, so if J were 0, the equilibrium is unique. What if J were infinity? If J were infinity, this is something I know. I would never make a choice. Suppose there's two choices and they have different probabilities. Would I ever choose the one with the lower probability? Never. Because there's an infinite benefit to shifting. Okay, so we already see now that the only equilibria for the probability vectors have to have equal values at the non-zero values. And of course, equal values of 0 at the other ones. You could make that a little more sophisticated and show the only stable equilibrium is all ones, or it could be 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, dot, 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 dot. See, that's very intuitive, isn't it? There's infinite utility to conforming. Those will be the stable configurations, is pure conformity. Everybody with me? So think about what we've done verbally, though completely rigorously. I started off by saying if J is 0, the equilibrium is unique. If J is infinity, there are L distinct equilibria. So if I start at J equals 0 and start increasing J, what's going to happen at some point? The number of equilibria will change, and we called that a phase transition. Okay, so the algebra proves all of that with the i's dotted and t's crossed, but you can see logically, it's very intuitive. You start at 0 for J, you know what's going to happen in infinity, and so the whole point is to figure out where, so you know there's a phase transition. The hard part is to figure out where it is. So there's a theorem for that, and this is what the theorem says. The theorem says the following. If you take beta times J and you divide by the number of choices, if that number is greater than 1, there are at least 3 equilibria. If it's less than 1, the equilibrium is unique. Let's think about that. Beta j is, so if I say beta j divided by L is less than 1, that's like saying beta j is small. Why would a small beta j produce a unique equilibrium? Well, either beta is small or j is small. If j is small, there isn't enough complementarity to create self-consistent bunching. That's best response function intersects one time. It matters for the behaviors, but it can't create multiplicity. The other reason that beta j could be small is that beta is small. What does it mean for beta to be small? Tails are thick. If tails are thick in the density, there's enough heterogeneity in the population to kill off self-consistent bunching. Because too high a fraction of the population has very large epsilon draws, and they're not going to be influenced by the bunching. There aren't enough people to self-consistently bunch. So that is very intuitive, isn't it? Why does the number of choices matter? Why would beta j be divided by L? So if I fix the complementarity j and the density beta, why would that it be harder, quote unquote, to get multiple equilibria if there's bigger L? The more choices I make, if the epsilons are independent, the more likely it is I'm going to get a huge epsilon draw that controls my behavior. So in environments where people are making many choices, if the errors are independent, it becomes very likely their choices will be dominated by unobserved heterogeneity. All right. So what I've done is I've now fully characterized the discrete choice model of social interactions. Again, do it, I know, tortuously quickly, but you see what the intuitions are. Private incentives interact with social incentives, interact with the thickness of the nature of the unobserved heterogeneity, and they control the number of equilibria for very intuitive reasons. What would happen if for one of the choices I raised the h of that choice high enough? Suppose there's multiple equilibria at h equals 0, but at but for the first choice I start raising h for everybody. What's going to eventually happen? I have to kill off the multiple equilibria, don't I? Because if I make the incentive for choice 0 big enough compared to all the others, people are going to move over to it, and there won't be enough people left over for self-consistent bunching. Does everyone see that? So once I relax the h equals 0 assumption, I have more phase transitions. So let me then link this up with something I talked about before. I put on the table an explanation for low high school graduation, high poverty. I said, well, it may be that in poor neighborhoods, they're coordinated on the low effort equilibrium, and in rich neighborhoods, they're more likely to be coordinated on the high effort equilibrium. That was my explanation of peer effects, and do you remember that? That was my 7th explanation in the list. You let me get away with that. There's something wrong with the explanation. If I said to you that I look at the poorest high school in the city of Los Angeles and it has a low graduation rate, and I look at Beverly Hills High School and it has a high graduation rate, is it enough for me to say, oh, Beverly Hills High is just coordinated on the high graduation equilibrium and the poor high school is coordinated on the low graduation equilibrium? You don't want to say that, do you? Here's what I think you want to say. You want to say that in the very affluent high schools, the incentives to graduate are so high, they kill off the potential for multiple equilibria. In poor high schools, where the incentives, because of the opportunities after high school are not so rich, that creates the possibility for multiple equilibria because the private incentives are not strong enough to swamp them. It's a very different argument. Do you see that? And so that's actually a general principle in these models. And that is, it's weak private incentives that create the scope for multiple equilibria. Strong private incentives will swamp the multiple equilibria. Okay. Now, if I wanted to push really hard, I claim that you ever understand the little piece of mathematics I talked through? I say to you that at a given incentive structure, private incentive structure, there's multiple equilibria. One way I could get rid of the multiple equilibria is to create incentives for one of the outcomes. That's just another type of phase transition. And so if I make an observation that certain communities exhibit multiple equilibria, that may be a statement that social interactions are strong, but it's equivalent to another statement. Private incentives are weak. There aren't opportunities for people. Now, if you think about it from that perspective, and you think about public policy debates, culture, people talk about, communities that are, jargon, cultural poverty, stuff like that. These things are sloppily thrown around. What I want you to see is from the perspective of these models, these are not meaningful distinctions. It's not meaningful to say something's caused by one factor. It's the interplay of private and social incentives. If I want to make an argument that some community is engaged in a behavior that is collectively undesirable, that's a fine thing to say, but it can only occur because the private incentives are such. And so the dichotomies in the public policy literature are falsified by these types of models, which are intrinsically interactive with respect to the mechanisms. Is that point clear to everybody? Please.
One thing though, in the affluent high school, why do we necessarily need the private incentives to be high? I'm thinking maybe you'll say we don't.
I didn't say I need. I'm saying if you wanted me, I think the interpretation of the high graduation rate is not that they fortuitously are at a good equilibrium. There is only one equilibrium there. And what these models say is when the private incentives are high enough, the equilibrium becomes unique again.
But it's not impossible to have a unique equilibrium without high
No.
incentives, right?
No, it's not impossible. I'm just saying that if the story I told you for explanation 7, there was something wrong with it. I don't know, it wasn't logically incoherent. It's just there was if you thought about it for a bit, there was something implausible about it. And this model revealed what was implausible is that the potential for multiple equilibria presupposes weak incentives. And so it's very important that if you want to make arguments about multiple equilibria,
That direction requires.
yes, that you have to focus on both sides of the equation, so to speak. All right. So I think I'm doing very poorly on time. So let me say one other thing. And that one thing you can do is the following: is you could take the same multinomial choice model and nest it and have a sequential logit model where in stage 1 groups are formed and stage 2 choices are made in the groups. That's simply a sequential logit model. You can work out that same thing and have a theory both of group formation and associated behavior in the groups. And then there's new roots to multiple equilibria, like who's in what group and stuff like that. So there's lots of things that could be done with the model, and they actually haven't been worked out yet. So that's another area where the literature is deficient, which is there has not been a full analysis of sequential multinomial choice models. It's only been done in one stage. All right, so I think given time, that's where I'm going to stop the discussion of theory. What I was trying to do, I know in supersonic speed, was to say, big idea number 1 was best response functions are upward sloping with complementarity theory of multiple equilibria. Big idea 2, segregation, because of complementarity theory of assorted matching. Put those together in 2 senses. One, you could write down a multinomial choice model, which was a nice econometric model, wasn't it? Had exactly the same ideas, and it clarified how private incentives, social incentives, and heterogeneity interact to control the number of equilibria. And what hasn't been worked out, and I just gave you the algebra of how you would work it out, is to write down a sequential logit model of group choice and behaviors in the groups that would be estimable, and it would give new roots to multiple equilibria. So what I want to do now is talk about the identification. I want to switch from theory to econometrics. So what I have on the table, in other words, I wanted to say that here are some ideas in the theoretical literature. Now I want to talk about the identification problems. So I have emphasized, and this is why I want to say, oh, look, isn't this cool, this multinomial choice model? It had a bunch of functional form assumptions in it, didn't it? I assumed I knew the error structure. I assumed additive separability between the 3 constituents of choice. Okay, those are all with loss of generality assumptions. The advantages were as a piece of theory, it facilitated understanding because I could work everything out and see exactly how private incentives, public social incentives, and heterogeneity interacted. That's a virtue of even though it means it was reliant on the functional forms. But second, that was a likelihood function. So in other words, any identification problems immediately can be studied. That's a little bit of background. All right. So what I want to do now is talk a bit about identification problems in the social interactions literature. So, okay, I'm taking the theory hat off, putting the econometrics hat on, and what I want to put on the table are various identification questions. And the way that I'm going to do is I'm going to start off with linear models, and that's what the Mansky, Mansky's classic 93 paper has 2 types of analysis. One is for non-parametrics, one is for parametric. I'm going to focus on the parametric. All right, and so I'm going to focus on so-called linear and means models. These are linear regressions, and even though they may not constitute the frontier of econometrics with semi and non-parametric methods and the like, this is what the overwhelming majority of empirical papers focus on. And so we want to know what is identified in these models. All right, so the way I want to think about this is to say there's an outcome omega. I'm going to keep my I's dotted, but I'm never again going to, there's a constant term in all of this stuff, so we don't care about that. But there's going to be three things that explain individual behaviors. There's going to be a vector of individual specific characteristics, x's, they're observable, and that's what I meant about indexes. It's family background, it's stuff about you. There are going to be variables that function at the level of the group of the individual. Those are y's. And the third thing that's going to matter is the expected average choice in the population of the group. So I'm sitting there and I was deciding how many Hawaiian shirts to buy when I was a senior in high school. They were very cool in 1976, I promise you. And so I was influenced by some X's, I was influenced by some Y's, and I had a belief about the average number of Hawaiian shirts that were going to be purchased by my classmates. Everybody with me? That's it, that's the model. Okay. So that's the question is, if I had data on individuals, what would I observe? I'd observe their omegas, I'd observe their x's, I would know what groups they're members of, and I'd hence observe their y's. And so I want to know, if I have data of that form, can I tell you what the values are of C, D, and J? Now notice, you could say there's a problem. First of all, everyone understand the model? I make a choice. Is determined by my characteristics, the characteristics of the group I'm a member of, and my beliefs about what people are doing. And the thing I care about is the average behavior. So if I said there's a problem here, there's not a problem. There's an issue we have to address. I have assumed that I do not know what others do. I form beliefs about what others do. That's why I put in M, not omega bar. One possibility is I have perfect information. That would be omega bar. Another possibility is I believe crazy things, no comment, and that could be an arbitrary M. All right. The point I want to make is when we write down models with incomplete information, we always have to take a stance on what it is agents know, their information sets, and how they process the information they have to form beliefs. Now, if you think about it for a second, if I had a data set and I said to you, their behaviors depend on their beliefs about something, and I have no theory of beliefs, then this model is empirically useless. Because any behaviors I observe can be reconciled by saying they just happen to believe this. Right? So in other words, it's as if I had a latent variable, and for each person I could make up any arbitrary M I wanted. So that we would be done. That's a very general model, but it's not an interesting form of generality because it doesn't let us progress. The baseline in economics is to assume a form of rationality. In macro, it's called rational expectations. Since microeconomists are embarrassed by macroeconomists, they call it self-consistency, or they call it the Bayes-Nash equilibrium. And the real point is the following, that the logic of economic reasoning at the baseline is to circumvent the unobservability of the beliefs by requiring the beliefs have some relationship to the information available to the analyst, as well as, of course, the information that's available to the actors, and by implication, you then take a stance on what's available to the analyst. So the logic of rational expectations econometrics is to circumvent the unobservability of beliefs by requiring the beliefs are consistent with the model, which creates the possibility you can then uncover the belief structure. Everybody with me on that? So this is kind of what you learned in macro in some permutation, but I want you to see the logic of rational expectations econometrics is very powerful. It lets us move from these latent variables called beliefs to saying we can still proceed because we assume the beliefs have conformity to the world in which the beliefs were formed. Now, an obvious answer to that would be we don't believe that people are rational in the way that I just described. In other words, we aren't walking, this is kind of almost cocktail party criticism of economics to say we don't walk around with models in our heads and form beliefs. What makes that non-cocktail party criticism is to take an alternative stance on belief formation. because then we can once again discuss the environment. So I'm not defending rational expectations as true with a capital T. I think it's a very powerful baseline for doing analysis, and then you can step back and ask how would I, in a principled fashion, relax the rationality assumption and ask what gets preserved in terms of the logic of the model, what it is we can still recover from data. All right, so that's our question. So I'm going to start off, so my question to you, as I say to you, I have the omegas, that's the outcomes, I have the x's and I have the y's. I'm going to assume agents have self-consistent beliefs, that's going to overcome the unobservability of beliefs, and I'm going to make nice error assumptions. I skipped, okay, those are nice error assumptions. What they say is the errors are uncorrelated across individuals, and they're not predictable given any of the information that's available to the agents. All right, let me translate that into English. X's and epsilons are uncorrelated. They're orthogonal to each other. That sounds like something you like in OLS. So that's why I call them the nice error assumptions, because I'm ruling out self-selection and correlated heterogeneity. Remember I said that there were 3 identification problems, the classical one, self-selection and correlated heterogeneity. So I'm ruling the second 2 out. So let's think about this for a second. I have a regression. I'm asking whether or not C, D, and J are identified. Suppose M were observable, counterfactual. If I could observe X, Y, and M, and I said to you, are C, D, and J identified, what would your answer be? You would say yes if X, Y, and M were linearly independent. That's what you learned in your first regression course. The identification of the parameters of a linear model required the linear independence of the regressors. So that's our question, isn't it? I ask, are social interactions effects identified? It's the same question, isn't it? Because after all, I can always form empirical estimates of M. Actually, what I could do is replace M with the averaged realization, and I could then instrument for it. So it's exactly the same problem. So we have to figure out whether or not X, Y, and M are linearly independent. If they are, the model is identified. If they are linearly dependent, the model is not identified. Self-consistency means the following. Everybody's subjective belief about the expected value of the behavior in the group is the expected value of the behavior in the group. That means I take the equation, I run the expectation operator through both sides, I rearrange terms, and therefore the self-consistency condition is that the expected value of the average in a group is k plus cx bar g, in other words, the average of the x's, plus dyg, the average of y is by definition y, because it's a group thing, it's the same for everybody, divided by 1 minus j. Okay, that's elementary self-consistency, is it not? Everybody comfortable with that equation? So now we have a very concrete question. This model is not identified if that object is linearly dependent on x and y. Well, it is linearly dependent on y, isn't it? So relative to my initial equation, that m variable is related to the y variable. What differentiates m from y? X bar. So the reason that it's possible that m, the expected average choice, is not linearly dependent on the y's is because the x bars, the average of the individual effects, also is moving the m around. That's the key to identification. Now, let's think, is everybody with me on that?
Actually, not 100%. No, I mean, wouldn't we need the axis to move in a certain way to offset? I mean, like, you just...
This is a necessary
the
condition.
term is very clear, as you pointed out.
Necessary condition. So what I said was omega I equals kxi plus dy plus jm Okay, so I'm saying I need this thing to be linearly independent of this. This is xi, this is x bar g. If this weren't here, m would be linearly dependent on yg, and the model would not be identified. So what we would need, the necessary condition, is that the x bars move the m's around in a way that this is no longer linearly dependent on this. That's necessary, not sufficient.
Break that down. How? I see what you're saying, but we have to specify what that relation is, right?
Yes, I didn't say it is. I said it might be. So let me give you, here's a model. What if this were true? If I said to you my theory of behavior is that the y's, the group level variables, are the averages of the x, is this model identified? No. Because if this is my theory of the relationship between y and xi, in other words, every y is the average of an xi, then m must be linearly dependent on y. So in that special case, identification fails. And that is the reflection problem. So in other words, in the Mansky's analysis, he assumed that everything that we measure at a group level that matters is an average of an x. Okay, does that make sense? So, no, it's not the only case, but it tells us a necessary condition for identification to hold. It is necessary that there be at least one x variable whose group level average I omitted from the original equation. Remember, if I said to you that xg is the average of the x's, then for every x, its average was a y. Right? If I put in other y's, that doesn't help me, does it? The only thing that can make the m move in a way that's not linearly dependent on the y is if x bar g is affecting it and did not appear in the original equation. So the necessary condition for identification is that we have at least one x variable whose group level average was not included in the original equation as a matter of theory. Does everyone see that? What does x bar g give me? It gives me the instrument to move the m around in a way that is not linearly dependent on the y's. So that's the instrumental variables interpretation of what's happening here. Okay, so that is the reflection problem. And it's just a species of, it's the classic simultaneous equations question put in the context of a social interactions model with expectations. That's not to diminish the significance of the paper, it's to make an observation as to where it lives within the broader literature on identification. Is everybody clear on the mathematical condition? I need to be able to move the m around in a way that's not linearly independent on the y's. The self-consistency condition said that m does depend linearly on the y's, but it depends on something else, which is the x bar g's. So the answer is maybe it's identified. It depends on what assumptions we're willing to make a priori with reference to exclusion restrictions. In this case, the exclusion restriction is an x bar from the original specified set of y's. Everybody with me? That is what we mean by a priori. We bring information to bear, and it can facilitate identification. All right, and so the key to understanding the reflection problem was this idea that if people are affected by the average behavior as well as the average characteristics of others, the average behaviors and the average characteristics from the logic of the model move together. Okay? Now, identification is not whether variables move together, it's whether they're linearly independent or not. And so what the reflection problem did was it identified conditions under which the endogenous influences and the contextual influences really were linearly independent, and this is the special case I gave you. All right, and so that's been the focus of much of the identification literature, is trying to tease out the conditions under which we have this linear dependence. So the paper that I mentioned, Larry, Raji Jayaraman, and Buzz Brock published in JP in 2015, has a result. Did you talk about the result? Okay. So there's a result in that paper, which I will put on the table, though I did not make a slide. It says the following, and that is, the reflection problem is non-generic. What we mean by that is the following. If you think about all the linear social interactions models that are, in a certain sense, consistent with the quadratic model that Larry gave you on Tuesday, what differentiates those social interactions models? It's the weights that are assigned to people in the socio-matrices, right? So some of them give equal weights to everybody. That's the linear and means model. Other ones give unequal weights. What the genericity result says is the following. If you take the universe of socio-matrices, each socio-matrix, there's another model, isn't there? I can ask, is this model identified? Here's your socio-matrix, is this model identified? You take the set of all socio-matrices that are consistent with our economic theory, and I put them into two categories. You with me? These are the socio-matrices such as if we assume these are true, the parameters are identified. Here's another set. These are the socio-matrices such as if you assume these, the model is not identified. What you can show is the dimension of the set of identified models is higher than the dimension of the set of unidentified models. That means the failure of identification is non-generic. Metaphorically, if you thought about if I thought of the plane as all of the candidate social interactions models we could work with, and this curve was the set of social interactions models where identification fails, the curve is lower dimension than the plane. It's exactly the same thing. And so in this sense, identification is freakish. Now, you might say to me that you're 100% certain that these are the right socio-matrices. In other words, the linear means model is the true model, and therefore who cares about the others? If you believe that, that's fine. Then you don't care about genericity. Our position is that we have no reason to believe any of these models, and so therefore the focus on non-generic models is not essential. Okay, that's comment one about the paper. The other comment about the paper, to toot our collective horn a bit more, is we take a different stance. In other words, what I gave you was identification results that said if you assume this social structure is linear and means, then it's identified under conditions A, not identified under conditions B. I said a second thing, which is if you assume the social structure, then almost all linear models are identified. Our objection to the literature is not just the focus on non-generic results. It's something bigger, which is we question the validity of the assumption that the researcher knows the social structure in advance. And so most of what our paper asks is, what can we identify if we don't assume I know the social structure? And the good news is, actually, there are things you can identify. All right? Now, why would that be true? Suppose I wanted to identify his influence on her. And this is what we know. I don't see very well, so I don't know her. I know him. Okay? Everyone with me? So there's a link from me to him. There's a link from him to her, and there's no link between the two of us. What am I? I'm a fantastic instrument, because he can use me to instrument the effect of him on her. And so that's an idea that you see in a very nice paper by Bramoulet, Jabari, and Fortin, who point out that there's lots of information in social structures. And so I just gave you one example of it. So what I wanted to say, without belaboring the linear model too much, is there are conditions where the linear and means model is identified. They have to do with the ability to construct instruments for M, which don't linearly depend on the Y's. That's result number one. What I've hand-waved about, because I didn't put any slides up, is there's something special about the linear and means model. In other words, generically, linear social interactions models are identified. But the weakness and the limitation of that statement is they assume that you know the social structure in advance. and where I believe the frontier is for this type of work, is to understand what you can identify when you do not know the complete social structure. Now, is it the case that we know some things about social structure? So let me give 2 examples. One of them is we may know something about some aspects of social structure, such as what there may be conformity effects in the classroom, and there may be a public goods game for students, families contributing money to a pool to buy musical instruments. That's partial knowledge. The other example is social networks. If I do a survey on a social network, what do I ask people? I say, who are you connected to? Does that tell me the intensity of your connections? No, that's the thing that's missing. But it does tell me where the zeros are, who's not connected to who. And why was I a good instrument? Because we weren't connected. So it's the zeros that are useful, not the ones, as it turns out. And so social networks information represents partial information of social structure. And so these are areas to explore. All right. So what I want to do instead, even though I'd like to talk about our work and praise ourselves ad nauseum, is
Shut down, cancel, guys.
I was scared. It was like Star Trek when they had the self-destruct button on the... Good. All right. We've got another hour. Okay. So where I want us to be is in linear models. The way to think about it is linear and means model is a special case, is a leading special case, and all the action is going to derive on whether or not I have an x whose x bar doesn't appear in the equation. It turns out that there's a non-genericity to the identification of failures there, and that says us something important about where the right frontier is for social interactions research and my judgment on econometrics, which is identifying partial assumptions. The other thing I want to do is identify variations of the linear and means model, which will tell us something new about identification. So here's an example I started off by saying linear models, identification may fail, right? Okay. What about a nonlinear and means model? So here's an example of a nonlinear and means model. Is rather than say that my behavior depends on the average, my expectation of the average of others, it depends on a function of that. And I'll assume the second derivative of that is non-zero, so it can't be linear. Everybody with me? So the question then is this model identified? The answer is yes, it is generically identified. In other words, if you told me mu, and mu is nonlinear, it will be identified. And the reason for that is very simple, and I don't think I wrote it out. Okay. What broke identification in the linear and means model is that M was linearly dependent on Y. In the nonlinear and means model, there may be functional dependence of M on Y, but it's no longer linear dependence. This is a very important point. The failures of identification were not because the regressors were functionally dependent on one another, it's because they were linearly dependent on one another. And in fact, there's an underappreciated paper by McManus in Journal of Econometrics in 1993 who showed that nonlinear parametric simultaneous equations models are generically identified. The logic of that paper, if you extrapolate here, says nonlinear social interaction models in very broad classes are generically identified. So a message I want on the table, in other words, is that nonlinearity, it can be your friend. If it's parametric nonlinearity, things are identified, even though in the linear analogs they are not. The intuition is it's linear dependence of the regressors that breaks identification. Okay, so that's an idea I want on the table. Here's a second question. What about dynamics? The non-identification results I gave you, and in fact most of the literature focuses on static models. So the idea is my behavior depends on what others do today. Well, I could think about variations of that, couldn't I? For example, I could think of a model in which my behavior today depends on what I thought last period. Okay, so I make decisions based on kind of, I have stickiness in my behavior. I don't update instantaneously. If I were to write that model out, the expected value of what I do today would depend on the x's today, the y's today, and what I believed yesterday, right? What I believed yesterday depends on the x's yesterday, the y's yesterday, and what I believed 2 periods ago, so on and so forth. So if I recurse that backwards, it turns out that my beliefs today depend on a linear combination of the x's, x bars, and the y's, not just the contemporaneous ones, but their entire history. L is just the lag operator. So if that's the case, what's going on here? Actually, let me show it up here. So if I think about equation 11, the question for identification is whether or not mgt minus 1 can be linearly dependent on ygt. But in this model, mgt minus 1 depends on the entire history of the y's. That breaks linear independence. And so in backwards-looking dynamics models, the identification problem disappears. What about forward-looking models? In other words, I could say that my behavior today depends on my beliefs about what people are going to be doing next period, right? This is a sort of model you know and love from macroeconomics, right? So the dividend stock price model says the stock price today depends on my beliefs about the stock price tomorrow, as well as the dividends today. When I was buying Hawaiian shirts in the summer of 1975, I had beliefs about the average Hawaiian shirt consumption that was going to occur that fall, didn't I? So in other words, many times when we write down dynamic models of behavior, pardon me?
They were very wrong.
Not in Southern California. Mine? Yes, yes, yes.
Another network effect.
That's right. In Rochester, New York, God knows what you guys were wearing. But in Burbank, I assure you. All right, so does everyone see that? In other words, again, if we think about dynamic environments, another way that we would move away from this atemporal linear and means model is models in which my beliefs about the future affect current behavior. So you already know from Hansen and Sargent, there's a way to solve, it's a very simple solution to that model, is that the expected value of my behavior today will be the present discounted value of my belief of the future values of the variables that are contemporaneous. Once again, that tells us something, which is that there will be a break between the linear dependence in the atemporal models and the linear independence in the temporal models, where the expectations are formed in different periods from the other variables in the system. Okay. And so a fancy way of saying this is that when the variables that I form beliefs over are embedded in dynamic frameworks, they generate instruments for them. The entire histories of the x's and the y's become relevant in terms of what determines my beliefs at a point in time. And that, again, is part of the genius of rational expectations econometrics, is that there's many criticisms you can make, but the genius is these models generate their own instruments. Because there's closed systems that say these things are forecast errors and therefore orthogonal things, and the internal logic tells me what determines the latent variables. Okay. I wanted to say something briefly about hierarchical models. Hierarchical models are the way that sociologists engage in social interactions analysis, and I want to put this on the table because they actually have a somewhat different structure from what we do in economics, and I think it's kind of an appealing structure. So, the way that I described the econometric social interactions models was additively separable. I said there's something you do, and what you do is determined by individual stuff plus social stuff of type 1 plus social stuff of type 2. The sociological perspective is different. It would, again, this is maybe oversimplifying, is again, if I think about people in groups, what I would say is, in this group, there's a particular relationship between individuals' characteristics and their outcomes. But that relationship is determined by group characteristics. And so the easiest way to write this down would be to say that each group has its own constant term and its own coefficients for the individual characteristics, but that those two variables depend on, the coefficients depend on the social context. Does everyone see the difference? So the idea in the hierarchical models is each group has characteristics to define a background that determines the nature of the transmission of the individual characteristics to the individual outcomes. And so if you were to substitute in, and I'm oversimplifying the hierarchical model, I'm killing off a lot of random effects for sociologists. At the end of the day, what happens is the hierarchical model is going to create is going to basically have cross products of the terms. Think about the equation that I started with. If I say the coefficients linearly depend on group variables, and I substitute 16 and 17 into 15, I'm going to get xi's multiplied by the group variables. Now, I have to be careful about the way they get multiplied and sort of respect the algebra correctly. But when I do that, at the end, I end up with an equation that looks like this. And so we have a fairly complicated system, don't we? Now this is the closest, this is the analog, in other words, between the hierarchical models of sociology. Is everyone clear? There's a substantive idea there that matters. And that is that the group characteristics define a context. Within the confines of the context, there's a specific linear relationship between the individual characteristics and the outcomes as before. Now what's nice about this, or what's interesting, is if I take the expected values on both sides, okay, there's some, you just calculate that. Notice the following. The expected value of the behavior is a nonlinear function of the x bars and the y bars. We already covered that case, didn't we? Nonlinear means models are identified. So in fact, there is no reflection problem in the hierarchical literature. So when somebody says, well, sociologists didn't worry about the reflection problem, my answer is they shouldn't have, because they were working, well, I should say our answer, since Larry and I wrote the paper that did this together, our answer is that they shouldn't have, because their models actually had embedded in them a type of nonlinearity that made this a non-issue. Now, again, it's not the statement that it's not a non-issue because this model says so. I'm just saying in this context, you think about things differently. And so the message to this I want on the table is you have to take the substantive social science stance, from that derive the model, and then determine identification. If the way that we conceptualize social interactions is that they're defining these background contexts so that we have these piecewise linear systems, as it were, that's a very different environment to study identification from the initial linear means model. And so it is not ex post a surprise that the identification issues are qualitatively different. Okay, so I think in the interest of time, so that's really all I wanted to say about. Linear models of social interactions with nice properties. What I mean by that is I've gone through the different manifestations of those models, all under the assumption that the errors were independent across the individuals and there was no self-selection. Okay, so I want to stop there, and I want to now talk a bit about the issues of unobserved group effects and self-selection. All right. Before I go on, by the way, that's supposed to be unobserved group effects, not observed group effects. Okay. So I actually kind of like that word. Okay. But before I go on, are there any questions? Pardon me? Yes, no, that's good. Good. Are there any questions on what I've covered so far? You'll get the slide, so my ranting there'll be some justification for it. But I want you to see the key logics. Linear model, I have to be able to move the endogenous effect in a way that's not linearly dependent on the contextual effect. There's a way you formalize that algebraically. It turns out everything is driven by the relationship between the x's and the y's. Once I move to models that are nonlinear or meaningfully dynamic, identification will hold. If I think about genericity with respect to social structure, identification holds. And so what I want on the table, in other words, is that with respect to the classical identification problems, I think that one should not, there's kind of a mythology almost in the social interactions literature that somehow nothing's identified. That's simply not true. In other words, that if you look along the different dimensions, some models are identified, some are not, but typically the identification is generic as opposed to non-identification. So So when I want to back off now is on assumptions. And so let me start with the one that I don't like because I prefer to end on a high note. And that is the one I like, which is, okay, and that is what do we do about the presence of group effects? So I gave the teacher example verbally. The way I would talk about it algebraically is I would say I had my model, and now I add another variable. It's called alpha g. And so I get a reduced form, so on and so forth. And what's going to be critical here is that alpha g is going to be correlated with mg. And it could be correlated with the other regressors. And so the introduction of group effects by itself automatically kills off identification. So in other words, if I said to you, there are these group effects here, and I have no theory of them whatsoever, in this linear model, identification has to fail. Why is it? Any parameters you gave me for the social effects, I'll say they're 0, and I'll mimic the social effects with my choice of alpha. So put differently, if I introduce fixed effects across the groups, unobserved teacher quality, I could never, if you don't constrain the teacher quality in any way, I can't say anything about the environment. Because any theory any claim you had about the parameters, I'll say there's something else, and I'll adjust my unobserved teacher quality choices to exactly offset the consequences. Okay. So there's two ways to think about how to proceed. And so another way to understand it is once I have group effects, I'm getting correlations between the unobserved heterogeneity alpha g plus epsilon and m. So what are the two strategies for that? Well, the strategy that's the preferred, the one we all know and love is instrumental variables. And so the idea would be to come up with variables that don't appear in the equations that are correlated with the m's, but are not correlated with the fixed effects. Okay. Now that's a perfectly sensible, legitimate strategy. The problem, of course, is we may not have them. Now and so when I say we may not have them, that's one reason that, as I said, we like these things we call natural experiments is they provide instruments. In other words, that they represent cases where we can credibly argue this variable is correlated with the variable we wish to instrument, but should not appear in the equation otherwise. Those are always matters of judgment. In some cases, the judgments are easy, sometimes they're hard. But you want to be recognized they are matters of judgment. The second approach, of course, would be to change the analysis and look for a panel. Okay, again, this is elementary stuff which you already know. If I have panel data, I can difference out the fixed effects. And so I don't put this on because this is something you already knew this. But what I wanted you to see is that the solutions that exist in the literature, be they differencing techniques or instrumental variable techniques, they typically are purely statistical exercises. In other words, the instruments are not generated by the internal logic of the model. They're deus ex machina that appear from some external source, or the structure of the data, because as a panel lets me difference. This is why I think these are the hard problems, because we cannot bring to bear economic theory on them. Okay. That doesn't mean to throw up your hands and quit. It means you have to recognize that there's going to be some types of limits to identification. They're going to require judgments. They're going to require thinking hard about what data are available. Please.
So just looking at this equation, isn't it the case, so the presumption here is that you have individuals and groups and you have multiple groups, right?
Yes.
Right. So suppose it's the case that we're not doing linear means, but the social matrix is something else, right? Well, then can't that within the group just difference out the group effect without the group fixed effect, without having the left-hand side and the right-hand side disappear?
I should say there were results that exist in the literature on that, and it's a very good point. I think the Bramley et al. Paper has some results on that as well. And then there's other things like Brian Graham has stuff where you assume they're random effects, and there's ways that you can use variance contrast to get rid of it. So once there are cases, I don't want to say it's insuperable, but they're going to be, I call them statistical assumption approaches, because they essentially say this is how you have to be able to difference something out in a certain way. And so maybe you think it's an unfair use of the word, but I mean, it says, here's the statistical framework. You ask, is there a transformation of the data where the fixed effects disappear? And the transformations are not motivated by economics. They're merely mathematical.
Well, but often it is can have group effects at the level of the whole group. Or you can have, you have a more complicated social interaction inside of the group, right? These might be edge effects of the graph,
Yeah.
something like that. And even though we don't have much of a theory about how they actually work, we might have a theory about where they're placed.
Mhm.
And so even here, after all, I'm justifying I exist. Theory plays a role.
Mhm.
And it's not, I think, just a statistical manipulation, but the general, the fact that you have this equation is a theoretical statement.
Okay. Friendly, I take it as a friendly amendment, and I agree. Thank you. Let me make one other comment about the differencing, or about the fixed effects. One thing will still be identified, and that is C. Because within a group, all the alpha is a constant, and y is a constant, and m is a constant. So you can use the cross variation in the m's to uncover the C. And Larry's observation was, well, there may be something about the social structure where I can look within the group to handle the way that we difference out the alpha, which I can then exploit cross-group differences. And so that point was well taken. All right, so as I said, since I don't like that problem, let me talk about one I like better. And that's the self-selection one. So I want to put on the table an argument. And I'm not happy. I apologize. I did a lousy job in these slides. So let me go back here. All right, so self-selection. The issue is very simple. If I say to you there's self-selection, it matters if the following statement is true. And that is the conditional expectation of epsilon given these things no longer 0? After all, if epsilon were still orthogonal to the other objects in the regression, whether or not there's self-selection is no longer relevant, is it? So in other words, point number one is when we're talking about identification and the consequences of self-selection, we want to be very precise. It matters if this conditional expectation is no longer 0, because that means the orthogonality condition is violated. All right? So the point I want to make is the following, and that is, as I said before, unlike the fixed effects or the correlated heterogeneity, we may have a way of modeling the self-selection. All right, and so my argument is going to proceed as follows, and that is, if I think about this thing here, this is an identity. The expected value, the epsilon always equals its conditional expectation plus what's left over, right? Suppose I miraculously gave you that conditional expectation. In other words, I opened up the statistical abstract of the United States and it had those conditional expectations. How would I proceed? If I knew this thing, I would subtract it off omega. What would be left over here? Xi. Xi by definition is orthogonal to the other regressors. So if I knew the conditional expectations, then we're back to square one, and I go back. I have my original theorems, don't I? Okay. So unfortunately, the statistical abstract of the United States does not have the column called conditional expectations of your regression errors. That's where economic theory comes in. And so I want to go back to the classic selection correction of Heckman. So what was Heckman's idea in thinking about self-selection? His idea was intuitively to say that if I had some way, if I knew this thing, obviously I would simply use it to adjust this error so that in the new equation, the errors are orthogonal to the regressors. So the flash of genius was to realize it might be possible to estimate this thing. And in particular, what he was able to show is you can estimate it up to a constant of proportionality. And so that's the idea of the selection correction. So what you should have presumably have seen in econometrics earlier is you are able to estimate this thing up to a constant of proportionality. You get something that's an estimate of a constant proportionality of this. That's stage 1. Stage 2, you add it as a regressor. Okay, everybody with me? And so what I want you to see, what I'm putting on the table, in other words, is that if there's self-selection, again, one strategy is instrumental variables. The other is to model the process of selection, and that's what I called model expansion. And so in model expansion, what you would do is you would model the process of the self-selection in such a way as to be able to construct an estimate that is proportional to that conditional expectation. You add it as a regressor, and then you can do exactly the same analysis as before. Okay, and so the logic of the Heckman selection correction, the original parametric one, said that that each of the possible groups that you're a member of had some payoff. Each person chooses the group with the maximum payoff, and you compute the conditional expectation of the error given these things by making a parametric assumption about the covariance of these two objects here. So that's where the Mills ratio and all these normality assumptions come in. The modern control function approach relaxes the functional form assumption so you can have semi-parametric control functions. But the idea is the same thing. You do is you first model the process, the endogeneity of the selection of the groups. You use that to construct a function which you add to the equation, which controls for the fact in the original regression the conditional expectation was no longer 0. All right? And so in that sense, this is what I meant by the theory-motivated approach, the constructive approach, I arrogantly called it, which is to say you use economic reason to account for the self-selection and you adjust the model accordingly. Now, why am I going through all of that? Because I want to make an argument. This, in essence, is what it would mean to apply control functions to the linear models we've been talking about. This applies to any linear model. I'm doing it for linear means for expositional purposes. In other words, intuitively what I did was I said that the equation that I started with is different. So I start with omega. The new equation is omega equals cxi plus dyg plus jmg plus something that is proportional to the expected value of the errors given the groups. Okay, so I just added a regressor. Everybody comfortable? That's what a control function is. I add a regressor. Here's the part that is interesting. Does that regressor affect identification? In other words, I gave you a bunch of conditions for identification in the linear and means model. I said, for example, the linear and means model, if there's a one-to-one mapping between the x's and the y's, is not identified. I also said to you a necessary condition would be if there's an x whose x bar is not a y, then it might be identified. I further said if there's a nonlinear relationship, it might be identified. Everybody with me? So now this is what I want on the table. Suppose I have two environments. Environment number 1, there's a one-to-one mapping between the x's and the y's. Every x is an x bar that is part of y. Under random assignment of people to groups, that model is not identified. That was what I went through earlier. Everybody comfortable with that statement? That's world 1. Identification failed with random assignment. Now I go to world 2. The groups are endogenously determined and there is selection on unobservables. That's the Heckman world. My question to you is, are the parameters of that model identified? The answer is they might be. Even though under random assignment identification failed, identification can hold under non-random assignment. Okay, first of all, let's think about why that could be true. And I want to do, let's see, the algebra is right here. Okay. What were the two routes to identification? I needed an x whose x bar isn't there. Is the selection correction an x? Yes, it's individual specific. My selection correction is different from his selection correction. If I make $7 million a year and I live in Palo Alto, there's a different selection correction than if I make $10,000 a year. right? The selection correction itself is an individual level variable whose group level analog did not appear as a matter of theory. So in the linear world, that's a route to identification. The second comment is generically select control functions are nonlinear. There's only very special hairline cases where the probability structure makes them linear. And one of the things that will determine whether I'm a member of a group is what I think the average outcome is going to be. I choose to put my children in this school district because the expected value of the average performance of kids is high. And so in other words, selection corrections, control functions convert linear models into nonlinear models with respect to M. And so if you a bit of reflection, what you will see is those are very different worlds. The world of random assignment with linear functions, identification, as I said, let's assume it failed. If I allowed took the same type of people, but I had self-selection into groups with a nice selection on unobservables, so identification might hold. Now, the way that I've talked, that it's heuristic, and it's functional form dependent. I assumed a linear regression, all of that. The question is, first of all, that sounds weird, doesn't it? I just said random assignment was bad for identification. I thought, sometimes people incorrectly, by the way, say random assignment is the gold standard. That's not a good thing to say. And maybe this is an example of why it's not a good thing to say. Random assignment, is everyone clear? Random assignment identification fails. It's possible under self-selection, in other words, assignment on unobservables, we get self-selection facilitating identification. My question is why? It sounds superficially it's counterintuitive. I claim actually it's intuitive. Well, if you think about it, it's intuitive. What is self-selection? A behavior. So I cheated in the following sense. I said my first world, there's only one behavior to observe, what people do conditional on random assignment to groups. Over here, I get to see two behaviors. I get to see what groups they chose and what they do conditional on being in a group. That's more information. And so if it is the case, and that's the condition that's necessary for identification to reemerge, if the choices of the groups encode information about the social interactions, then they help me identify them. So to play that out, I told you a story which is really, remarkable about immigrants who are paying 70% to live in Palo Alto High School. The fact they're doing that tells me something. Remember I said I just can't say Palo Alto high schools are great because these kids had unusual parents. But that's not the end of the story, is it? The point is that these unusual parents chose to go to Palo Alto School District. That is information about the nature of the social interactions. And that's what I was trying to emphasize in this example I'm giving you, which sounds paradoxical, but it's not if you think correctly about what it means to relax the random assignment assumption. I relaxed it along the dimension of the allowing for a greater variety of choices to be expressed. All right? And so that is delivering, so that is cashing in the bill, the promissory note that I had to come up with an example of an individual level variable whose group level analog as a matter of theory was not part of the model. The control functions exactly they fit the bill. And the reason they work is there's additional information on what motivates people. All right. So let me end very briefly with some comments about identification and discrete choice models. Okay. Let me say first that the slides that you'll see, they're just about binary choice. What I say will also apply to multinomial choice with appropriate caveats. Okay. The first thing is there is no reflection problem for the binary choice model. What I mean by that is even if there's a one-to-one mapping between the x's and the x bars and the y's, that model still is identified. The reason for it is probabilities are nonlinear functions of their determinants. What broke identification in the linear model was when the m's were linearly dependent on the other variables. In the discrete choice models, that can't be true. Now, can't means that you need to have an environment in which the support is fat. In other words, the x's and y's need to move around, but that's going to be key to the identification argument. So that's the first point. Classical identification holds. Here's ways to get intuition for it. And I hinted at this before. If I look within a group, I can identify the C's if there's enough variation, if the X's vary. If I look across, so within a group, that gives me C. It's looking across groups that give me D and J. In order to get D and J, I need M and the Y's not to be linearly dependent. What's going to save me on that is that the M is the average, is a fraction of people doing something, and that will non-linearly depend on the Y's, as long as the Y's move around enough. Not that there's any, it's not identification infinity, it just needs to be, they move around enough to reveal the implied nonlinearity. Okay. Now, there's a 2.5-page proof in the paper I wrote on this with Buzz Brock that will prove, that dots the I's, but I just gave you the full intuition for the proof. All right.
Sorry, to be clear, do you need, obviously it would be nice to have full support of both all X's and Y's. You don't need that for all of them, right? You need it
No,
for-
no. Now, in the paper, we made that assumption because that makes the proofs easy. It is a sufficient condition. It's not necessary.
Did you characterize it as necessary?
No, they're messy. No, well, you should. They were too hard. I don't know how to do it. You should do it. But you can see what I would need for the necessary condition is that there has to be enough movement so they aren't linearly dependent anymore. It's very hard to say what that would mean outside of particular. If I knew the functional form, then I'm done. And if I don't know the functional form, I don't know how to say it in a good way. All right. So what I wanted to end with was the following. Okay, so the first point is many of the identification problems in linear models do not naturally carry over to the nonlinear models, and discrete choice models are a species of nonlinear models. The thing I wanted to end with is to make the observation that there's actually things you can do about fixed effects in discrete choice models that you can't do in linear models. What I mean by that is if I could write down a discrete choice model which has a fixed effect for each group, I claim that there's actually something new to think about. So what I want to do is go back to linear models are kind of like linear best response functions, aren't they? So there's always, the equilibrium is going to be unique. If the slope were greater than 1 in any place, it's greater than 1 everywhere, there's no equilibrium. So these models are actually theoretically boring. In contrast, discrete choice models generate things such as this H-shaped curve, where if the complementarities are strong enough, you can get multiple equilibria. My claim is multiple equilibria are themselves things that could help us. Let's think about it. I gave you an example earlier. I said I have classrooms with identical microcharacteristics. High, low, high, low, high. There are two explanations if they're identical classrooms in terms of the microcharacteristics. High equilibrium, low equilibrium, high equilibrium, low equilibrium, or good teacher, bad teacher, good teacher, bad teacher. If I assume that there are no fixed effects, hence no teacher quality effects, then the fact that the identical groups are polarized like that would be evidence of multiple equilibria, and hence big J's. My problem is, what do I do about those? Maybe the teacher quality varies across the groups. Everybody with me on that? So if I make no assumptions about teacher quality, I can't say anything. If I assume the teacher quality is identical across all classrooms, then I can say everything. Maybe there's something in the middle. And what I want to put on the table is, since fixed effects cannot generate multiple equilibria, only J's can, that's where we might get some action. So here's a way to think about it. Intuitively, what I want to say is, suppose this is where I might get identification. I observe two communities. Everyone with me? This is a rich community, this is a poor community. This is a highly educated community. This is not a well-educated community. Suppose I told you that I knew those things, yet the kids here are doing better than the kids here. In a model without social interactions, that's not possible. Or, I'd say it only can be done by two things. Either social interactions or fixed effects. Everyone with me? Now, I want to call something a pattern reversal if the fundamentals in this community say that it should be doing better, whatever, better only there's some numbers higher under the fundamentals, but I get the opposite in practice. So if I have a high-income community with low test scores, low-income community with high test scores, I call that a pattern reversal. In other words, the fundamentals are not consistent with the outcomes. Everyone with me? My claim is that if I observe pattern reversals, that may be evidence of multiple equilibria. Maybe it's evidence of fixed effects, but it could be multiple equilibria. So let's think about that for a second. I have classrooms in a rich school which have lower test scores than a less affluent school. I said, well, I'm not sure. Maybe that's because the social interactions put the poor school at a good equilibrium, or maybe the good school has better teachers. What if I said to you, my assumption is the distribution from which teacher quality comes is better for the rich school than the poor school? Very plausible assumption, isn't it? So stochastic dominance. I didn't say it's true, I said it's plausible. Then I am allowed to say the following. If I assume stochastic dominance of the fixed effects, the teacher quality, so it was drawn from a better distribution in the rich school than the poor school, if the test scores were reversed, then my interpretation is that there are multiple equilibria. If I conclude there are multiple equilibria, what have I concluded? That J is positive and big enough to produce multiple equilibria. Did I tell you what J equals? No, I just said it's big. That is partial. That's a different type of partial identification. That's what I want to put on the table. That a route to partial identification in these models is to ask whether or not one can adduce evidence of multiple equilibria. The fact of multiple equilibria does not pin down the value of J. It doesn't even give me a nice interval in the way the bounds literature typically does things, but it tells me something else. It says that in this environment, the social interactions are strong enough to produce multiple equilibria. And that's an interesting thing for us. The final result I want to give you very quickly is the following. Here's a thing to think about. Suppose there were multiple equilibria. I have a bunch of groups, they're all identical. Everyone with me? But there's multiple equilibria. What would the density of the average outcomes in the groups look like? It would be multimodal, wouldn't it? If there's two equilibria, there'd be some fraction here, some fraction here. Okay. So that tells me that maybe there's something about the histogram, or the empirical, actually I should say the probability density of average group outcomes that multiple equilibria reveal. So here's the theorem. The theorem says the following. If it is the case that alpha comes from a unimodal distribution, then it has to be the case that for every average outcome, there's some combination of the y's that is also unimodal. What does that mean in words? Let me say it in words. Okay? If the alphas are unimodal, and I look at all the groups that have probably 30% of the people are going to do something, the distribution of the y's has to be unimodal. The reason for that is that if J were the only way you can get bimodality is that people are piling up at different equilibria. The reason that somebody's at the given average is either they're at a high equilibrium with one y or a low equilibrium with a very different y. Does everyone see that? Otherwise, there's a smoothness. In other words, to be at that y, to be at that average, there's going to be the y's that are closest to it, there's going to be a set of y's that are close to each other that typically generate it. The only way to get multimodality is via multiple equilibria. Okay, that's a very subtle and weird theorem, and I know I didn't say it in a very good way, but what it tells us is that's another route to trying to uncover evidence of multiple equilibria. You look at a given average, and you ask, is there disparities in the y's, multimodality, in the y's that generate it? If there are, well, what happened to the stuff in the middle? Why didn't it generate it? The answer is because these guys got polarized at the multiple equilibria. So that's something that is yet to be used in any empirical work. I do want to make a comment. There's a mistake in the literature. Some papers claim that if a model has multiple equilibria, the outcomes must be multimodal. That is false. The way to think about it is that if a model has multiple equilibria, then the data are coming from a mixture density. There's some probability you draw from this mixture, that's one equilibrium, some probability this mixture, that's another equilibrium, so on and so forth. Mixture densities are not necessarily multimodal. They can be unimodal. This is the correct theorem on multimodality and multiple equilibria. So you discussed the paper that gets that one wrong, but I don't want to say it in public. All right. Bottom line is to say that if you're working with discrete choice models or models with multiple equilibria, since the multiple equilibria are evidence of strong social interactions effects, you can separately ask, can I come recover evidence of multiple equilibria? Because by itself, that implies J has to be big. And that's a form of partial identification. It's a different route to identifying things. It is unique to the discrete choice nonlinear world because the linear models, as I said, are unique equilibrium models. Okay, inhale, exhale. I'm only 3 minutes late, and I only skipped 1/4 of the slides. And I apologize for that, but thanks for coming, and I'll see some of you in office hours. Take care.